first of all, I will go through the content that we are going to cover. For that, let me go to cisco.com. So just go to cisco.com, and that's where you would get this tab called Learn. Under Learn tab, you would have like the certifications, and then say browse all certifications. You just go there, and then if you scroll down a little, then you would see that there are many different types of certification available when it comes to the Cisco. You can go for the entry level certification, associate level, but what about the Cisco SD-WAN? So remember, the Cisco SD-WAN certification comes under the enterprise technology. So technology would be enterprise, and the level would be professional level. So if you go to CCNP enterprise professional level, just click there, CCNP enterprise. And then if you scroll down once again, then you should see one exam called ENSDWI. So that's 300415. That's the exam code. So that is the exam that you need to take to become the Cisco SD-WAN certified. And the topics, like if you want to know about the topics, then simply click on 300 and 415 ENSDWI. So if you click there, then you can also get to know that what is the price for this exam. So that is 300 USD plus taxes. GST is extra, and the conversion charges will also be extra, right? So obviously there will be some additional cost in addition to 300 USD. If you look at the exam overview, the review exam topics, so we can review them. So these all are the exam topics. Basically, I would say that these are the topics that we need to cover. So if you look at there, right, so we can also download the complete list of topics in PDF format, or maybe we can simply review the topics section by section. So if you look at there, Cisco has divided this entire training into 6 different modules. So the module 1, 2, 3, 4, 5, 6, in total 6 modules are there in this training. The module 1 is all about the architecture. So in architecture, we are going to have a discussion around that how this is built actually, like which all different components are participating, right, in Cisco SD-WAN. How many different components we have and their roles, responsibilities. Like in Cisco SD-WAN, when we talk about its components, then those components are divided into 2 different categories. One is called the controller components. The second is called, like maybe data plane devices. So mainly you would we would talk about the control plane and data plane, and of course the management plane is also there, the orchestration plane is also there. So all the control components will come under orchestration, management, and control plane, whereas under data plane you would have all of your routers. Routers are still there. Do not think that SD-WAN has replaced the routers. No, the SD-WAN is a way to control or to manage your routers only, right? I will talk about them as well later on. But for now, if you talk about the architecture, under architecture, you are going to talk about each and every component participating in this Cisco SD-WAN technology. And there are many components. As you can look at here, the vBond, vManage, vSmart. Now, Cisco has also renamed those components, okay? Now, orchestration plane is called validator. The Cisco, the Catalyst SD-WAN validator. Even the Cisco SD-WAN is been renamed as Catalyst SD-WAN now, right? Cisco Catalyst SD-WAN. Obviously, there is a renaming. I will also talk about that in more detail. But for now, let's use what Cisco has given here in the topic list, right? So it's a list of topics, right? So you're gonna talk about the vBond, which is a validator, or I would call it orchestrator. And we have got a management plane, vManage. Trust me, 90% things will be done on vManage, 90% or maybe more than that. So you are going to play around the vManage, like you're going to manage everything from vManage actually, whether those are control components or, the routers. So whatever you would like to configure in your network, you will be doing it from your management plane, which is your vManage. So vManage is going to be a very, very critical component over here, right? So we will be, covering each and every component here in more details. But for now, since I'm just giving you the introduction of all the topics, so I'll just cover the basics. You have got the control plane where you have got vSmart, and then data plane. That is all about the managed routers, right? So data plane is all about the routers. So in SD-WAN, routers are responsible to build IPsec tunnels, or maybe, the GRE tunnel, the BFD sessions, right? So The BFD is nothing, bidirectional forwarding detection. So BFD is not something new. That I mean, this is not something that you are. Murli, do not ask the questions in chat. Please go ahead and unmute yourself and ask the questions. I will not be reading chat. Most of the time, the chat is closed, right? Today, I will keep it open, but I mean, just to inform you, please do not ask the questions in chat. And there is a reason. I use multiple screens. So ideally, I am focusing on the screen which is shared with you. So even if chat is open, it is open on different screens. So in most cases, I do not really focus on the chat. So I would request each one of you to ask your questions by unmuting yourself, right? So let's try to make it more interactive. And since it is not kind of like webinar or so that I have someone to monitor the chat. So that's the reason that I'll not be reading the chat, or maybe I'll not be focusing more on the chat. But today it's fine. So Molly, the question that you did ask for, what date did Cisco make the delta changes on renaming? So you don't really, I mean, I even don't remember that, but I know the version, the exact version when Cisco renamed that. So 20.12, when Cisco launched 20.12, or for iOS XE 17.12. So when Cisco launched that version 12, in that version, they renamed all these components. Like as of now, we are covering them as orchestration plane or maybe management plane, but in reality, Cisco has already renamed them, right? From version 12 onwards. So in your organization, if you are still using, let's say, version 9 or maybe version 6, then you are still gonna look at, or you are still going to find all your old naming convention. So the new names will be used by, like new names will be visible to you on your dashboard if you are using 20.12 or the older version of operating system. So Cisco declared the renaming during their conference, one of their conference. I don't remember the exact date, but then when they released the 20.12, that's where they renamed all these components, right? Okay. So the architecture is all about like how does SD-WAN work? Cisco SD-WAN works. How many different components will be participating in Cisco SD-WAN and their roles and responsibilities. So that is all about the architecture. So basically, upon completing this section 1, right, or module 1, you would understand that how it is working. You would not understand it fully. Why? Because we do not really perform any labs during module 1. The labs will get started with module 2.0. So that's where you start with controller deployment. And that's where you start learning more about the Cisco SD-WAN. Because in module 1.0, we only cover the theoretical concept, like, okay, this is the vManage, this is the roles and responsibility of vManage, then this is vSmart, this is the role and responsibility of the vSmart, right? So I mean, everything you cover from a theory perspective under module 1.0, but then your labs would get started at module 2.0, where you get actually started with the controller deployment, right? So you would start with the controller deployment in module 2.0, right? And that's where you would learn that how you can deploy your controllers on-prem deployment, right? So basically, let me tell you a couple of things here, right? So there are two ways to deploy your control components in Cisco SD-WAN. One, you can deploy them in cloud, such as Azure, AWS, right? So in those cloud, you can deploy your control components. The other way is to deploy them on-prem. Like you can also perform the on-prem deployment. So when I say on-prem deployment, which means like if you have got VMware ESXi servers, right? Or maybe you are using some other hypervisor such as KVM, right? So on top of those hypervisors, like you have got on-prem servers, and that's where you are deploying all your control components. So that option is also available, on-prem deployment. In fact, in this content, you only see the description, describe. There are no labs, but we will be performing labs for the controller deployment, and we will be doing the on-prem deployment. So I will be teaching you that how you can perform the on-prem deployment. So when I say on-prem deployment, which means that we will be using VMware ESXi servers, the ESXi host, where we will be deploying the control components. However, in your lab, like there is a lab that you would have access to. So in that lab, the controllers are already hosted. All you have to do is that you need to bring them up. You need to bring them up. You don't have to install them. So I will be installing the vManage or vSmart, each and every component I'll be installing manually in right in front of you. You would get that exposure that how do we perform that kind of deployment over the VMware ESXi or maybe KVM. But in your lab, all the components are pre-deployed. However, you would be bringing them up, right? You will make them work. Like you just have to power on all those components and you need to set up them, right? So you will be setting up all your control components from scratch, but you don't have to install them in your lab. But I will be covering, like me myself, I'll be covering the deployment of the control components over the ESXi servers, right? So you don't really have to worry about that. So we will be performing on-prem deployment of the control components. Also, you need to understand about the certificates, because everything when it comes to the Cisco SD-WAN, all the components are talking to each other. They all are authenticating to each other using the digital certificates. Like for example, if I'm trying to access the Cisco website, so this website is a secure website. You can see there is a lock button, right? It says connection is secure. Why it is secure? Because of the digital certificate. You can see this certificate is valid. I mean, I got a certificate from Cisco web server, right? And then my browser, my laptop has said or has defined that certificate as a trusted certificate, as a secure certificate. So for the authentication purposes between my laptop and the Cisco's web server, a certificate is being is in use. Actually, you can see that certificate now, right? So it says that this certificate was issued by the hydrant ID server CA01, right? To whom? To Cisco, Cisco Systems Inc., right? And the common name is also there. But also if you go to details, and then if you go to subject alternative names here, which is also known as SAN. So just look at the subject alternative name, right? So this is learning.cisco, learningnetwork.cisco.com. And that is the domain that you are trying to access. This is how the authentication is happening between your machine and the Cisco's web server, right? So in similar way, digital certificates are very important when it comes to the authentication between the different components in Cisco SD-WAN, right? So always remember that the certificate will play a very, very important role. Now, there are a couple of, examples that I see in every session, right, where people are familiar with the digital certificates, and there is a set of participants who are not really familiar with the digital certificate, that how do they work, how authentication takes place based on the certificates, what is the root certificate, what is root CA, what is CSR. So I would request you all, right? I would request you all to go through that process once by your own. Like try to Google the information that what are the digital certificates, how many different types of digital certificates you have got, who is the CA, and sometimes even you get the subordinate CA, also known as intermediate CA, right? And then there is a terminology called root cert chain, right? So you should be knowing that what is the meaning of root cert chain. And also you need to understand the identity certificate. And to obtain the identity certificate, you always going to have a requirement of the CSR, certificate signing request. So I would request you all, please go through that process once. I mean, it's not about the SD-WAN only. It is everywhere. Even if you are accessing facebook.com, google.com, nowadays each and every application is secured, right? Every application is accessible with security, right? And security is achieved by the help of digital certificates in most cases. So I would request you all, please read about the certificate. And everyone is using certificate every day. Like I'm hoping that everyone is accessing internet every day. Whenever you access any application over the internet, right, ideally those applications are secured by HTTPS. And whenever that application is secured by HTTPS, which means that you are using digital certificates there. So I would request you all that you need to understand that how digital certificates are working, are participating to make this communication between your laptop and the Cisco's web server or F5's web server or any web server securely. So how that connection got secured by the help of digital certificate. Please go through that. I'm sure that some of you will understand that, some of you will not understand. that process. Then later you can ask me the question, but at least you need to start with that. So I would request you all to understand, to have some understanding around the certificates. If somebody is already working on F5 load balancer or maybe on firewalls, then probably they are already aware that what type of capabilities certificates have and how does it work. Or maybe if some of you are working on maybe securing the application server, maybe you are working on web application firewalls, then probably you are already aware with the certificate process, right? But if someone never had a chance to work on certificates, I would request them all to go through that process once. Then we have got the troubleshooting there. Like just in case if your control connectivity doesn't come up between the control components, sometimes it would happen that you may have to perform troubleshooting just in case if control connectivity between the controllers is not coming up. And it's easier, right? I mean, it's easy to perform that troubleshooting, and we will be learning that as well. Like I'll give you some possible causes, right? And also like we will go through some issues, and then we'll be having those discussions during the session, right? That how we could fix them in just in case if you fall into those types of issues that I'll be discussing with you, right? But that's about the controller deployment. Then you have got module 3. Module 3 is all about the router deployment, and that's where the actual SD-WAN functionality would get started, right? Because if you just deploy the controllers alone, right, SD-WAN is not going to work for you. So if you really want SD-WAN to work for you, obviously you have to deploy the control component, but also you have to deploy the routers. Without routers, then what will you be doing with this, with the SD-WAN, right? Because SD-WAN is there to manage your routers only, to manage your data plane devices. So this section is very, very critical, right? Again, I mean, I would say that each and every section is critical, but this router deployment is totally dependent upon the controller deployment. So let's say your controller deployment never got succeeded or never got completed, then do not even think about the router deployment. The router deployment is going to get started in the end once you are done with the controller deployment. So the objective should be for each one of you to get your controller deployed first successfully, and make sure that all control components have authenticated each other. They have established the control connectivity with each other successfully, and then only start thinking about the router deployment. Before that, do not even think about the routers, right? Because router deployment has totally dependency over the controller deployment. If your controllers were never deployed, or maybe some of the control components are having some issues, then do not even think about the router deployment. Then you are into problem. So first fix the control connectivity between the control components, and then only start working on the router deployment. And that's where you will start working on real routers, right? And the routers will be installed at branches as well as a data center, right? So you can install routers wherever you want. You can install, you can have them installed at remote branches, you can have them installed in your data center, you can have them installed in your regional offices, right? And in cloud as well. So not only you can install your routers at on-prem, but also like in cloud such as AWS or maybe Azure. That's where you could install all of your you could install your routers. Then we have got the Cisco SD-WAN data plane, right? So we have got this data plane, and then the TLOC, right? TLOC is there. Then dynamic tunnels. There is a concept of dynamic tunnels between the remote branches, between the routers installed at remote sites. We will have these dynamic tunnels in place. Then we have got underlay, overlay connectivity. So these terminologies like underlay, overlay. This is not the first time that we are hearing those terminologies here in Cisco SD-WAN. This is something that is quite old, right? I mean, whenever you implement the GRE tunnel, or maybe you implement the site-to-site tunnel, or maybe you implemented dynamic VPN, DMVPN, we always used underlay, overlay. And not only in case of the VPNs, but also nowadays there is a concept called fabric. So you have got like Cisco ACI for data center, then we have got SDA for enterprise switching, so we have got SDA. So even in fabrics you would always have these terminologies like, okay, underlay, then overlay. I mean, that's what you use. And within this section you have got the concept of the OMP. Now this OMP is overlay management protocol, and remember, this is a Cisco proprietary protocol. Its name is overlay management protocol, but not only it does management, but also it does routing. Like in overlay, everything is performed by OMP. All types of information is getting exchanged between the remote sites, or I would call between the routers will always happen through the OMP. So Cisco came up with a different protocol here, which is OMP, Overlay Management Protocol. And we would learn about the OMP in more and more details, that how does it select the best path, which all information it carries in its update messages. So that's all part, that's going to be part of this training. Then TLOC is their transport locator. Now this TLOC is very interesting thing, or very, very interesting component here in Cisco SD-WAN. The most interesting thing is that in Cisco SD-WAN, the IPsec tunnel between remote sites comes up automatically. Like if you have the underlay connectivity between remote sites, and in underlay, you can use anything you want. Like you can use layer 2 circuits like Metro Ethernet, you can use MPLS, layer 3 MPLS, you can use broadband, you can use LT, you can use internet lease lines. So whatever you opt, you can choose that. Because Cisco SD-WAN, not only Cisco SD-WAN, in fact, if you take an example of any vendor specific SD-WAN, all SD-WAN technologies are transport independent technology. So when I say transport independent technology, that indicates that at underlay, like for transport, you can use any technology. The SD-WAN does not require any specific transport to work. So you can make SD-WAN work over any type of transport. So transport is always called as underlay. That's your underlay. I mean, I believe that some of you are already familiar with those two terminologies like underlay, overlay, although I will be covering them in more details once we start with the module and so and so. But yeah, for now, I could say that transport is underlay. And over that transport, when you build the IPsec tunnel, that is called overlay connectivity, right? So ideally, whenever we had remote sites in past, so we always configured either IPsec tunnel, or maybe we always implemented DMVPN, and in some cases we were also using the MPLS, right? So that was like dependent, or that was depending upon the customer, that what type of connectivity they had, and based on that we always provided our solution to customer. But just imagine that you were building up the IPsec tunnel. So how much configuration you needed to perform manually? I mean, it was a lot. So that big pain has been removed by Cisco SD-WAN, and that has been fixed by SD-WAN, because in SD-WAN, the tunnels will come up automatically between the routers. The tunnels will come up automatically. The IPsec tunnel will come up automatically between the routers. You don't do anything. You don't do anything to establish the IPsec tunnel between the remote sites, because that is gonna come up dynamically, and TLOC is one of the major reason behind that. So if TLOCs are getting exchanged dynamically between the remote sites, therefore the IPsec tunnels will come up dynamically between the remote sites. So there is a huge dependency upon the TLOC for the IPsec tunnels. But those IPsec tunnels would come up between the routers dynamically. So it has eliminated or has fixed a big or a major pain point for the customers and as an engineer also. So earlier in DMVPN, we needed to make a lot of a huge configuration to bring up the tunnels between the remote sites. But now in SD-WAN, you don't do anything for that. You just plug in your routers and then tunnels will come up automatically. So even the GTP, zero touch provisioning, is supported by Cisco SD-WAN, right? So we will also have a discussion around that, right? But OMP is playing a big role, a vital role to make that work, right? Overlay management protocol is playing a very, very big role, important role, critical role, I would say. And OMP is a Cisco proprietary protocol. Always remember that. And then obviously we have got like some other technologies like VRRP, OSP, BGP. Now in Cisco SD-WAN, the biggest advantage you get that those existing technologies are not like, if you talk about the other SD-WAN vendors, they always have some limitations. Like, okay, I'm gonna support, let's say, OSPF, but I'll not be supporting ACRP. Maybe I will not even support OSPF across all the branches. You do not have those limitations with Cisco SD-WAN. So the biggest advantage that you get with Cisco SD-WAN is that the traditional technologies are still out there. Not all of them, not everything, but most of them is still out there, right? Like VRRP, OSP, BGP, ICRP is still out there, right? And that's what we needed actually in some cases, in few cases, and that is still out there. So you would get so many advantages by having all those the older technologies supported by the Cisco SD-WAN. Now, I'm not saying that other vendors do not support those technologies. They do, but they have got some limitations. Like I know, like with Silver Peak, and then with Velo Cloud, they have got some specific type of sites where they support like those traditional routing protocols. Not everywhere. So in most cases, they would support only directly connected subnets at remote branches. But here in Cisco SD-WAN, even if remote branches do not have directly connected subnets, let's say there is a need of layer 3 routing, so you need to implement maybe EIGRP, OSP, or whatsoever, you can still perform that. That is supported. The multicast routing is also supported by Cisco SD-WAN. And we're going to talk about the templates here and workflows here in Cisco SD-WAN, that what all different types of templates it does support, and how do we create those templates, and then how do we attach devices with the templates. So templates are actually configuration templates. So ideally, you are going to make the configuration onto devices by leveraging the configuration templates. And yeah, I mean, that's major thing that you do when it comes to the production environment, because in most cases, like, you can manage your devices through the CLI, but we don't do that. That's not recommended by Cisco. We always do that. Like, we always manage the devices by leveraging the templates. So we always go ahead and create the configuration templates. So that's what you would be doing. Once you are done, the next is policies. Once you are done with the templates, then you're going to start with the policy. Now you have got so many different types of policies, like control plane policies are there. So when I say control plane policies, which means that you can perform route filtering, you can perform TLOC filtering, you can modify the OMP attributes for your OMP routes, you can also modify the attributes for TLOCs. So that's what you can perform using control plane policy, and that's what we even did in past. So if you remember, in BGP, we can apply the route maps, route policies for the BGP peers, either in inbound direction or in outbound direction. And that way we can always play around the best path selection in BGP. And also we can perform route filtering. So that would be done by leveraging the control policies here in Cisco SD-WAN. Then we also have got the data policies. And this is again not something new for you. In most of you must have already gone through the data policies, or I would call it data plane policies. Like I'm not sure that how many of you have heard about the policy based routing in past, but this is an exact topic or similar type of thing or similar technology as we had in past, like policy based routing, PBR. So data policies are the enhancement into the existing policy based routing. So that's where you do implementation of, you do the implementation of application aware routing. Then also you do the implementation of traffic engineering. Also you do the implementation of service insertion, also known as service chaining. Like all those sort of things can be done using data plane policies. So that's what you will be doing. And then DIA, direct internet access, is also an example of the data plane policies. So these all are the policies, but not only that, but also we have got like QoS policies and security policies. Now, using security policies, you can apply some sort of security features, and those are pretty important features that you have got in Cisco SD-WAN, such as you have got application aware enterprise firewall, which means that you can have a firewall feature enabled on your router itself. So you're not bringing in a new firewall, you're not bringing something new. No, on existing router, on a Cisco SD-WAN router itself, you can enable this feature. Basically, you know what? In Cisco, we had a concept of zone-based firewall previously also. Like, this is not something new that Cisco has introduced, right? So Cisco already had a firewall feature called zone-based firewall supported on their routers. Like on their routers, we could implement zone-based firewall. We could leverage that zone-based firewall for many firewalling features. But now they have made it more advanced, and they have made it now application aware. So Cisco has added the application awareness to their firewall, right? Then we have also got the feature called IPS URL filtering, app SSL proxy, or maybe trust SAC, right? So these all features are supported by Cisco routers, right? But remember, for IPS, intrusion prevention system, or maybe URL filtering, or AMP, or SSL proxy, these features can be implemented on router itself, but you would be needing an additional software to be installed. Like, this is not something that by default your router will support for all these security features. You would be needing a small software which is called Unified Threat Engine, UTD engine. right? Unified Threat Defense Engine. There is a security app which has been introduced by Cisco for their routers, right? So that security app needs to be installed on your router to get the support for IPS, URL filtering, AMP, SSL proxy or TLS proxy. But yes, those features are also supported by Cisco routers. Now, at same time, I'll give you my recommendation that we should not be enabling those features on router. Why? Especially this SSL proxy will slow down the performance of the router badly, right? Badly. It will affect the performance of your router badly. So it is not recommended to enable those features, but yes, are supported. And just in case if needed, and you know that router has got enough resources available, then go ahead and install all these, install the security app, and then you can enable these security features. So that is all part of the security policies. Now, the integration with Cisco umbrella, you know, the integration with Cisco umbrella or maybe Zscaler cloud, because sometimes you would find customers who are already having the license or subscription for Cisco umbrella, let's say, right? So in Cisco umbrella, then you get different modules, such as you get DNS protection, you get the SIG secure internet gateway, all those sort of things. But then you know but then the integration needs to be done. Let's say customer already had access to Cisco umbrella SIG. Now, customer want all your branch routers or maybe all your branch users should have the secure internet access directly from the Zscaler or maybe Cisco umbrella SIG module, right? Then you need to make sure that from the branch routers, the traffic, the internet traffic I'm talking about, I'm not talking about the intranet. Obviously, intranet should get exchanged between the branches, or maybe it should come back to the data center. But then internet traffic should be going to Zscaler. So that integration is also supported by Cisco SD-WAN. I will explain you the concept that how you can do that, how you can perform, because we do not have subscription to Cisco umbrella or Zscaler. But yes, I will be covering like this is the template that you need to use, and this is how you're gonna fill that up. Then QoS policy is also there. So when it comes to the QoS policy, then you get like scheduling, queuing, shaping, policing, marking. Now, these all features are supported by Cisco SD-WAN, but do not compare it with your traditional QoS features supported by Cisco routers. All those features are still not supported by Cisco SD-WAN, like not everything, but yeah, most of the features are supported here. Most of the features are supported here. Then we have got this describe application quality of experience, like how do we set up that quality of experience and how we can make it a little better, how we can optimize the quality of experience or QoE. So that's what we will be covering. So that was the section 5. So section 3, 4, 5 is, are those sections, again, I would say section 3, 4, 5 are those sections where you have to work on daily basis, like day-to-day basis, right? On day-to-day basis. And then finally, this is section 6.0 management and operations, right? So you have got like authentication, monitoring, reporting from vManage, like you have got all those sort of things, and then REST API support is there. So it's about the management and operations. So even you can perform the software upgradation from the vManage. So these all are the topics that you would be covering under module 6. So these all are the 6 modules that we are going to cover during this training. So I've displayed, I have discussed that which all topics you would be covering. Now, the next thing that you need to understand is that, this Cisco SD-WAN, basically, originally it came from Viptela, right? Let me talk about little bit about the history as well now, right? So originally this technology came from Viptela, and earlier Cisco used to call it like, like Cisco SD-WAN. Now it has been renamed with Catalyst SD-WAN. Earlier it was Cisco SD-WAN, and even before that it was the Viptela SD-WAN. So let me just cover that. So Viptela SD-WAN. Now Viptela was a vendor. It was a vendor actually, right? And that's why they had their names like vManage, vSmart, vManage. We indicated Viptela, right? And in fact, for routers, they had a vEdge. They used to call their routers as a vEdge routers, right? So the V always indicated Viptela. So originally, this technology was or came from Viptela. in 2017 and during 2017 and 18, Cisco acquired this Viptela solution. And that's how the Viptela SD-WAN became Cisco SD-WAN. Viptela was a vendor, a separate vendor in the beginning. And this SD-WAN started somewhere around 2000, I would say 2000, during 2014 and 15. SD-WAN became so much popular. Cisco had their solution called I-WAN, but that was a flopped or a failed product from Cisco. Right? They had this I-WAN in place, but that failed actually. That got failed. And then Cisco found or saw that SD-WAN providers like Velo Cloud, CloudGenix, and then maybe Silver Peak, they captured market. And Cisco was like, they were too behind. They were so behind than other vendors, right? And then Cisco, what they did, they acquired the Viptela. And that's how Cisco started, selling out the Viptela solution. That's how Viptela became part of the Cisco, right? And then Viptela SD-WAN became the Cisco SD-WAN. In Viptela, they had a protocol OMP, and OMP was a Viptela proprietary. But since Cisco acquired the entire Viptela SD-WAN solution, so OMP became part of Cisco automatically. So now it's Cisco proprietary. Earlier it was Viptela proprietary, but now it is a Cisco proprietary thing. Now, remember one more thing, that in Cisco, when it comes to the SD-WAN, right, there are two solutions mainly. One is the Cisco SD-WAN. You can also call it like Catalyst SD-WAN. You can also call it Catalyst SD-WAN. And second is Meraki SD-WAN. That is another SD-WAN technology that Cisco offers to their customer. But remember that Meraki has got some limited functionality, limited features, right? So for small customers, or I would I shall not make that statement, but yeah, I would say that, like, for poor customers, right? When I say poor, which means that they do not have huge budget for their IT infrastructure, and you can opt for Cisco SD-WAN, or Cisco will offer them like you should go for this Meraki SD-WAN. But if customer want like more flexibility, more reliable network than Meraki, then they should go for the Catalyst SD-WAN. That is more expensive, much way expensive than Meraki SD-WAN, right? So that's where you will be using the Catalyst SD-WAN. Now remember that Meraki is also so popular nowadays. Don't take it lightly, the Meraki SD-WAN as well. Because in Meraki, you get the complete ecosystem. Like you get Meraki firewall, where the Meraki SD-WAN is supported. Then you get the Meraki switches. Then you get the Meraki APs. Then you get the Meraki cameras. And that's what all you needed. In an infrastructure, that's all you needed, right? You needed cameras, you needed access point, you needed switches, you needed the firewalls, and everything is managed from the cloud. Meraki has got only cloud-based controller. Everything will be managed from the cloud, and so easy to manage them, but so difficult to perform troubleshooting because you don't get the console access to any of those devices. So if something is not working, then it is so difficult for you to perform the troubleshooting. In most cases, you will have to reach out to your Meraki tech support, and even in maximum cases, they will also ask for, if let's say one box is not booting up, let's say the OS got crashed. Now there is no way to recover that. Then RMA has to take place. So I mean, it's easier but complicated. Troubleshooting, you have got like limited options in Meraki SD-WAN. Now in this SD-WAN training, we do not have Meraki SD-WAN. So just forget about the Meraki. In this training or during this training, we are not going to have any discussion around the Meraki SD-WAN, right? Now, before I get started with the SD-WAN, I would like to have a discussion around the SDN, software defined networking, right? This terminology. So what is SDN? So you can always call it like controller based networking, right? So what is software defined networking? It is a basically controller based networking. So when I say controller based networking, which means that you are going to set up a controller, a centralized controller, and from that centralized controller, you are going to manage each and every networking component, or I would say you are going to manage your entire infrastructure, right? from that controller, and that's SDN. That's an example of the SDN, software defined networking. Now, if you understand, let's say you understand the programming languages such as Python, maybe some others, Java, C, C++, right? If you understand those programming languages, then you can also build your own. You can also build your own controller. You can make your own controller, and then you can try to control all your network infrastructure from that controller. So that will also be an example of the SDN, software defined networking. But also you can purchase the solution from different vendors, like obviously from Cisco, you can purchase that, right? Now, when it comes to software defined networking within Cisco, we have got, like, as of today, 3 different technologies. One of them is obviously SD-WAN. And this is what we are going to cover during our training, right? During our training, we are going to focus on SD-WAN only. And then also there is a terminology called SDA, software defined access. This is another SDA based, that is another SDN based solution provided by Cisco. And then one another is the ACI, Cisco ACI, which is another SDN based technology offered by Cisco. Remember that SD-WAN is for interconnecting all your remote sites to data center or maybe to each other, right? So only managed routers are managed by the SD-WAN technology, right? Only managed routers or WAN facing routers, right? So for WAN connectivity between remote sites, go for SD-WAN. The SDA is for lane automation, basically, I would say, for lane automation in enterprise networks. So using as like in SDA, basically you use the Cisco DNA center, right? Cisco DNA center. There is a controller called DNA center that provides you a lot of different features, or that supports lots of features. And one of them is building the SDA, which creates a fabric for your switching environment. So a lot of things can be automated using DNA center. So in SDA, basically you create a fabric over your catalyst switches. So you're gonna use the catalyst switches over here, right? So for catalyst switches, you have got SDA, and for Nexus switches, you have got the ACI. See, the only difference between SDA and ACI, because see, I mean, there are so many similarities between those technologies like SDA and ACI. If you compare them, like in SDA and ACI both, you are going to build a fabric. Even in SD-WAN also the fabric is created. So what is fabric? It's a virtual networking, right? Or a virtual network. So virtual network is everywhere in SD-WAN, SDA, ACI, everywhere. But in SDA, you manage your catalyst switches by the help of DNA center. In ACI, like ACI is built using the Nexus switches. So the major difference between SDA and the ACI is the series of, or is the family of the switches. Like in SDA, you are using the Catalyst family of switches, whereas in ACI, you are going to use the Nexus family of switches. That is the major difference between the SDA and ACI. If someone wants to learn, let's say one of you ask me that, okay, how can we learn like end-to-end networking in Cisco nowadays? So remember that you have to learn all these 3 aspects, the SD-WAN, SDA, and ACI. Because in data center, like if there is a customer, for example, you are providing a support for a customer who is using ACI in their data center, who is using SDA for in their branch offices for catalyst switches, and also using the SD-WAN. Now, it is important for us as an engineer to understand the SD-WAN, to understand the SDA, and to understand the ACI. However, in most cases, you would find different teams supporting different technologies. Like there will be a different team supporting SD-WAN, there will be a different team supporting SDA, and there will be a different team supporting ACI. Make sense?
Yes, sir.
Okay. So these are the 3 different technologies under SDN when it comes to the Cisco. Now, this is all about Cisco. There are many other vendors, right? Like Juniper also has got this kind of similar things, right? Supported. And then, like there are many other vendors as well. Like you have got Nokia, right? So, however, here during this training, we are not going to focus on any other vendor, right? We are going to focus only on the Cisco. And that's where all these things will take place. Even out of these 3 technologies, we are going to cover only the SD-WAN, software defined wide area network, right? Now we need to understand the challenges that what sort of challenges we had before SD-WAN. Because That's only way to understand the benefits of SD-WAN. Without knowing the challenges that we had in past using traditional routing or traditional networking, without understanding the challenges, it would be difficult for you to understand the benefits of the SD-WAN, right? So I will draw one diagram here right in front of you, and then you would try to understand that how things were bad actually previously. So let's say there are multiple DCs. The DC1, there was a DC1 and there was a DC2, let's say. Then there was a branch 1, then there was a branch 2, there was a branch 3, and there was a branch 4, and many more. There could be different types of customers, but I'll take one example over here, right? Or one scenario. So there was an ISP. The internet connections were available in both data centers. And then there was a MPLS providers. And then you had MPLS connectivity from each MPLS provider at your remote sites. Just like this. Ideally, we had this kind of architecture, especially for the banks in past. Like ideally, you would have this type of architecture for your banking customers. Like in most cases, you had this kind of architecture. Now, what could be the challenges or what type of challenges you had? Can anyone explain? Anyone on this call?
Yeah, I will explain some couple of points here.
Okay.
So, yeah, the main drawback is like the internet traffic, like for every branch, the internet backhauling to DC. So this is one of the main drawback because like we are utilizing like more bandwidth of MPLS. MPLS links are very costly. And second one is like some kind of reliability, like whenever we require like actual application traffic, like it may be having other traffic like other internet traffic, so QoS things we need to implement like at branch level. And scalability also, whenever we required to grow our organization, we have to plan, we have to plan, and budgetary and everything will be there. And third one is some cost. So if you go like a legacy network, like we have to pay more amount to MPLS link, and we have to maintain all data centers and branch level and iOS license everything.
Okay. Now, Gangadhar, I have got a counter question here. Let's say there is a bank, right? Even today, they are using only MPLS, right?
Yeah.
They still want to deploy the SD-WAN. Why? Why would you suggest them to go for the SD-WAN? Even they are using just MPLS, let's say, in their branches.
Yeah, like in SD-WAN, like there will be like a automatic overlay tunnel between branch to a data center, right? So the conversation should be fast compared to MPLS, and it's like a lot of features will be added, and we cannot like do all the configuration at branch level. We can control from the centralized.
Okay, good explanation. Now let me start, right? I will give you a couple of points and I'll just be very specific here, right?
Sir,
So
can I interrupt?
yes,
Sorry. We already have MPLS core network to then why we need this SD-WAN on top of it? Are we not overloading the? I mean, like what to say, overheads?
yeah, absolutely. I'm coming to that point. That's what I said. Like, let me explain now. Let me dig more into it. Okay. I'm going to answer your question now. I'm starting now, right?
Thank
Okay.
you, sir.
So if you look at this diagram, This is pretty much kind of a standard diagram, especially for the banking customers when you talk about the traditional networking, right? This is how we used to have like internet connectivity, right? Like each data center would have a larger pipe of internet, right? Then internet traffic will be backhauled into the data center from the remote branches. And then that's how they will go through the, they would have access to the internet. Now, there are many challenges that we had actually. Let me start one by one, okay? For example, now, like let's talk about today's scenario. We're using Office 365. Let's take an example of Office 365 or maybe Dropbox at same time, right? There are many SaaS based applications, software as service, right? That is being provided by different vendors. Now, if you are still using this way of networking, like especially right in front of you, so there is a user at branch level, let's say they are sending an email or maybe they're receiving the email. So how the flow is gonna work, just in case if they are using the Office 365. So each user will backhaul to DC first, and then they will go to internet, and similarly they will come back, like from internet back to DC and from DC to branch. That would add latency. And the features, you're getting more and more rich. It is becoming more rich actually. The Office 365 is becoming more and more rich every day, right? You're getting more and more feature, and as soon as you get more features, you need more bandwidth. So if you're using Office 365, the users would have some technical issues, like users would have some issues with their experience. So when I say that they would have some issues with the experience, with the quality experience. So the problem would be like the email will get delivered late. Email will get like email delivery will be late, right? This is one of the most common problem that you might face. Why? Because MPLS is so expensive, and in branches, let's say you are having just 2 Mbps of bandwidth, right? And then everyone is backhauled into DC, and then you are going to the internet. So that's one common issue that you have. Like the users would have so much of latency while sending email, receiving email. In fact, Microsoft Teams is having issues, right? That's one of the most common issue with this type of design. And that is not applicable just for Office 365, right? That is applicable for all SaaS based applications. Whether you take an example of Salesforce, or you take an example of Dropbox, or maybe just Box. So you would have problems with each and every SaaS based application. That's one issue with this type of architecture. Just one. I mean, that was the issue number one that I explained. Now, issue number two, I'm not sure that how many of you have experienced this, but in most cases nowadays, like the applications are heavier than before. Like earlier, we had pretty much light applications, needed low amount of bandwidth, but nowadays we are having heavy applications, right? Which needed or which require more bandwidth. So you have to increase this bandwidth, right? The MPLS bandwidth at a data center as well as at branch level. And if you're doing so, the cost will get increased, definitely. That's problem number two. Problem number three. The problem number three would be, I'm not sure that how many of you have fallen into this kind of issues in past, but just in case you had an ACL applied, let's say, on your WAN facing interfaces. Let's say you had an ACL, and unknowingly that ACL was updated by the engineer somehow, and then you lost access to your device. Now, is there any way to fix that issue? No, unless you have some field engineer in place. So you have to ask your field engineer to go back and to give you the console access and to share a screen over some, using some way so that you can fix that problem, right? I mean, I don't know how many of you have fallen into this kind of issues, like when device got locked. And not only this ACL, and even sometimes the ACL is applied on line VTY. So sometimes even you modify that ACL and then you lose access. Then you would not be able to recover from that situation unless you have some field engineer in place. And sending field engineer at remote location sometimes might take 24 hours, 48 hours, and even more. So problem. Sometimes you might set down the interfaces, the WAN facing interface unknowingly. Obviously, we had the solution for that. Like you could configure the EEM script on routers, that in case if WAN facing interface was shut down, then you should recover it automatically. But how many of you can do that or did that before? How many of you performed this thing? Maybe maximum 10% of you. So in most cases, if your WAN facing interface goes down, everything is down. Problem number 3 or 4, whatever it was. Next problem, your traffic, even though you are using MPLS, it is a private circuit, but still your traffic is going through the service provider network. And if service provider is capturing your data here, your data can be seen by the service provider. So it is a risk, security risk. So over MPLS, in past, we used to configure the get VPN, GET VPN. And that configuration was so much complex. So we had that issue as well. Now, in some cases, we also faced we also faced a scenario where there was a branch where we could only have the broadband connectivity. There was no internet lease line in that area. There was no MPLS connectivity, but we could get the static IP. So you got broadband connectivity. Then how you would connect this branch to your data centers now? That's where you had the concept of maybe IPsec tunnel, GRE tunnel, IPsec/GRE/DMVPN. Now, the configuration of IPsec tunnel or GRE tunnel, or obviously you were not using GRE because of the security, but we used IPsec and DMVPN a lot. But the configuration was so complex. The troubleshooting was complex. That is another problem. The next problem, what about monitoring the devices that you had in this device? You would use some third-party device, third-party application to monitor, like you would be using QRadar, although QRadar can be used for many different purposes, or maybe you would be using SolarWind. Like you have to use some sort of NMS, network management system, from where you could manage all of the devices, all of your circuits, you could monitor them, right? So you would have to pay a third party again to monitor the health of your network devices. That is extra cost. The next problem would be, let's say you need to bring in a new site. Now, whenever you needed to bring in a new site, first solution architect would start working on that. Then implementation engineer would arrange one field engineer who is familiar with the networking, who is familiar with the device configuration as well. Then probably you would take the remote access. Rack and stack obviously is a common thing. Even in SD-WAN, you have to perform the rack and stack, but then the remote engineer or maybe the field engineer would have to share the screen and then will give you the access, and then you will be doing the configuration remotely. A lot of challenges that we had basically to bring up a new site. Like, it's not that straightforward, right? It's not that easy to bring up a new site. Now, in branches, the next problem. In branches, let's say you had one MPLS from Tata, the other MPLS was from Airtel, across all your remote sites, remote branches. The Tata is primary, The Airtel is secondary across all your branches. Fine, you did that. And you are using maybe BGP there, right? Between PE and C. So you used maybe AS path attribute or maybe local preference whatsoever to make or to configure MPLS as a primary service provider and Airtel as a secondary. But now management has decided to reverse it. Now management want you to configure MPLS as a primary, Airtel MPLS as a primary, and Tata MPLS as a secondary for some of branches. How are you going to perform that? Don't you require to go to each and every router manually and to modify the BGP configuration everywhere? Why? Because each branch router is having its own control plane. Every router has got its local configuration, the BGP configuration. Don't you think that you have to log into each and every router and then make the changes to achieve this requirement? So that's another problem. Now, let's say you needed to modify the SNMP community, because you found that your community was compromised. And then management has decided to change the SNMP community across all the devices. How would you do that? Again, you will have to log into all devices across the data center and the branches. What about if you have got 1,000 branches? So how much time it will take to update that SNMP community string? Now, let's say you have changed the NTP server IP address. You modified the NTP server IP address. How much time it would take to go and update the NTP server IP across all the network devices? Just think about it. Now, let's say you changed the AAA server IP address. How much time you think that you would take to update the AAA server IP address across all the devices? Now, let's say you needed to take the backup of the devices. Now, tell me that how much time it will take for you to, let's say there was a change that, where you were touching nearly 50 devices. So if you're touching 50 devices, so before making changes onto devices, you have to perform pre-checks. And even after making changes, you have to perform the post checks. Will you be doing it manually? Yes, we used to do it manually. So just think about it. How much time it will take and how much time it was taking. Like we had change windows for 8 hours, 10 hours if we were touching like 50 devices for a smaller change. Maybe you just had a change of updating the NTP server IP, or maybe updating the AAA server IP, or maybe updating the NMS IP address. 8 hours, 20 hours, 24 hours, multiple change windows, multiple set of changes, a lot of challenges that we had in past. So it's endless. I can keep going. We had so many challenges, and that's where people started that, hey, I mean, don't you think that we need something kind of like a centralized controller from where, let's say I needed to update the NTP server. I go and update it on controller, and then it will push the changes across all the devices automatically, and it will be done in a 2 minute, in 1 minute, in 2 minutes. I needed to update the AAA server IP, NMS IP address, whatever. Or maybe I needed to change the primary secondary path. I needed to establish an IPsec tunnel. I needed to onboard a new site. I shut down the interface manually. Is there any way to recover that automatically? Or maybe I applied the ACL and then I lost access to the devices. Is there any way to recover from that situation automatically? That's what SD-WAN provides you. That's what SD-WAN provides you. So it's not about the cost only. It's not about the MPLS only. There are many things that I can count on. Right? So that's what all things have been fixed by SD-WAN. SD-WAN is providing the solution for all those things that I have discussed so far, and it's endless. I can keep going. Have you understood? Have you all understood the pain points with the traditional networking now? Are you all comfortable?
Yes, yes.
And that's where we needed this controller-based networking, this SD-WAN, software-defined wide area networking. And I mean, SD-WAN is not the only one thing. As I told you that under SDN, software-defined networking, we have got SD-WAN, we have got SDA, then we have got ACI for the data centers. So for Nexus switches, you got ACI. For Catalyst switches, you have got DNA center. And then for WAN edge, for WAN facing routers, across data centers and remote branches, wherever you have got WAN facing, because WAN facing routers will be placed everywhere in data centers as well as in remote branches. And that's what you can control using your SD-WAN. So I hope that everybody understood now that why SD-WAN is needed. These all are the things. Now, in short, I would say now internet is moving to the edge. Like in each branches, internet is moving. Why? Because you have got so many SaaS based applications that you may need to have the access to. So like it is important for us to have the internet access at each branch level, and then we should be configuring DIA, direct internet access, for certain applications, especially for those SaaS based applications like Office 365, maybe Salesforce, for Dropbox, something like that. So SD-WAN is needed. Routers, your routers traditionally, they were not application aware, right? Those routers were not supporting the application aware routing. Now in SD-WAN, even they have introduced the application aware routing. Like for example, if you said, hey, for YouTube traffic should go via this link, you can do that. For Facebook traffic should go through this link, you can do that. Earlier it was not possible. Why? Because your routers were not having support for the application aware routing. They could perform routing based on layer 3 only. They never performed layer 7 routing. But now in SD-WAN, even your routers can perform the layer 7 routing. So you have got so many technical advantages of SD-WAN over your traditional networking.
So what was the first point you told, the disadvantage with that? What was the first pain point, the disadvantage with traditional networking, traditional WAN networking?
Sir, I don't remember
Backhauling
now
internet
because
traffic.
I don't even remember what all things I have told you, right?
No worries, no worries, no.
See, the things comes up from your
Got it, got it.
inner side,
No,
when you start a topic. So I'm not using
right.
any PPT here. Let me start using PPT so that you can be more specific. Okay,
No,
just a
no
moment,
worries.
please. And at same time, the video is being recorded, right? So later on, you can also refer it if just in case needed. The challenges: insufficient bandwidth because you had MPLS, and then security challenges were there, limited app awareness was there on the routers, no cloud app readiness, high cost, complex operations, right? So these all are the challenges that we had traditionally, right? And now in SDN, basically what you have done, the application layer, control layer, and infrastructure layer is all is been divided, right? And the advantage that you get, oh come on, hold on, let me go back a little. If I see that slide here, common business and IT trends, like more user requirements, users have more requirements nowadays, right? More applications are moving into the cloud, and that's where you get this SaaS, software as service, right? Even infrastructure as service is there. The branch sites are getting direct internet access at any time from anywhere, that kind of flexibility you want. And that's what is done, or what is achieved by the help of SD-WAN. So basically, the WAN requirement is evolving. It's not like earlier, like you just needed to backhaul everything into data center, right? It's not like that nowadays, right? So even if you are doing work from home, you need to have access to your applications. So I mean, you have got so many different user requirements, and that's where this SD and software defined networking comes into the picture, right? And SD-WAN is one of the component of SDN. So in SD-WAN, obviously you get the flexibility of opting for physical router and virtual routers. So virtual router can be deployed in your cloud. So obviously you can deploy the routers inside the cloud. Then you have got the on-prem or cloud for management. So you don't really have to purchase any third-party monitoring tool, as you get built-in monitoring feature on the controller itself. Then zero touch provisioning is supported. It's scalable. Why? Because the control plane and data plane have been segregated. You have got the centralized control plane in SD-WAN, and therefore it has become highly scalable now. And point and click to define your topology. Like for example, if you wanted to have hub and spoke topology, or maybe you wanted to have full mesh, or maybe partial mesh, so you can change the topology by leveraging some point and clicks. And then the underlay can be anything. It is a transport independent technology, flexible connectivity with any WAN technology. So you can still use MPLS, you can use broadband, you can use 4G LTE, you can use Metro Ethernet, you can use satellite connection. So whatever you have got, use anything. It is a transport independent technology. Then also it supports segmentation. So like if you have got different departments or maybe different types of networks, like you have got some compliance to be followed, like you have got a network where you have to have the PCI compliance in place or maybe HIPAA compliance in place. So you can segregate that network by leveraging the concept of VPNs, also known as VRFs. So in Cisco SD-WAN, the VRFs are known as VPNs. I'm not talking about the IPsec VPN. I'm talking about just VPN terminology here. So using VRFs, the segmentation is so easy. Even department wise, you can perform the segmentation. So like if you have got multiple departments and you don't want them to communicate with each other, then you can put them into different VRFs. And only intra VRF communication is allowed by default between the remote sites. So let's say there are 100 sites. At all 100 sites, you created two different VPNs, let's say, or two different VRF. One VRF for sales team and one another VRF for, let's say, for IT team. So sales team will never be able to get into the IT network, and IT users will not be able to get into the sales team. I mean, this is just an example. So you can perform the segmentation based on or by leveraging the concept of the VRF. And then you also get the single pane of glass. Like as I told you, vManage is a single pane of glass from where you do monitoring. Not only you perform monitoring, but also you do the configurations. Not only you do the configuration, but also you perform the troubleshooting. So everything is done from the vManage. And then you also get application aware routing. So as I told you before, that nowadays in Cisco SD-WAN, the routers have got the capability of the application awareness. So they can perform routing at layer 7, not only at layer 3. Earlier we saw that routers were supporting only layer 3 routing. So whenever an IP packet was arrived at router was always looking at the routing table, and based on that it took the decision. But now even router can take a look at the application, that okay, this traffic belongs to YouTube, and for YouTube traffic should go through that link or this link. So you can build your policies based on your requirements. Then you have got a data plane and control plane security. So for data plane security, as I told you, between remote sites, the IPsec tunnel will come up automatically. You don't do any configuration for that. You don't configure any pre-shared key. You don't have to be worried about that. Okay, this pre-shared key is in place for from last couple of years, so it's time to update that. You don't really have to worry about that. Why? Because the shared keys will keep on updating by the SD-WAN automatically. Then this technology is a cloud ready technology. Like you can perform easy integration with SaaS based applications as well as with infrastructure as service, IaaS. So if you have got a small data center hosted inside cloud and you want your on-prem sites, your on-prem remote branches, your physical branches to have access to the applications hosted in cloud inside the infrastructure as service. So the integration has become so easy in SD-WAN. And then you have got the overlay routing, right? As I told you before, that Cisco has got a Cisco proprietary protocol called OMP, Overlay Management Protocol, and that's the protocol that Cisco SD-WAN will be using in overlay. So the overlay routing is supported. So in overlay, routes will get exchanged between the remote sites. Does that make sense to all of you?
Yes.
Yes.
Okay, so I've given you enough for today, right? And tomorrow I'm going to start with the Cisco SD-WAN introduction. I will start with the different components of the Cisco SD-WAN. I'll give you the introduction about all of the components participating. Basically, we're going to cover the architecture, the module 1. So far, I haven't started with any module. I just gave you the introduction to the Cisco SD-WAN, the advantages, the challenges that we had in past, and then as I told you that the solution for all those challenges we have got in Cisco SD-WAN. Not only in Cisco SD-WAN, there are many other vendors as well. But yeah, since we are covering Cisco SD-WAN here, so I'll be talking about the Cisco SD-WAN only. Okay. So yesterday we had a discussion, like some overview of the SD-WAN. We had, like I explained the challenges that we had before, and then I said that we needed to have sort of controller-based networking, easy to implement, easy to make changes, easy to recover, easy to roll back the changes, like easy to onboard a new site. So we had and cloud integration, like kind of providing DIA, direct internet access, and providing security. So all those required things have been supported by the Cisco SD-WAN, right? And that's one of the reasons that Cisco SD-WAN is becoming more and more popular day by day, right? I mean, you can see that most of the customers either they have already moved on to the SD-WAN, or they have a plan to move on to the SD-WAN. Most of the customers have already moved on to the SD-WAN. Yeah, in India or maybe in Asia, I would say that the customers, especially in Asia, including Middle East, customers are still not really at good pace. At good pace, they are still not at good pace to migrate their traditional network onto the SD-WAN, especially when it comes to the WAN side technology. But I believe that that would also get a start sooner. So, like agenda, we already discussed yesterday, and then next that I would like to show you is the number of labs. So, if you look at the number of labs, we have got like somewhere around 51 labs that we are going to perform during this training. So, that's the total number of labs, and also you can review that by your own, because these PPTs are also available on your dashboard, the training dashboard. So, on training dashboard, and on your training dashboard under documents, you should see these PPTs already uploaded. So these all are the labs, and then next is the environment, the topology. So this is the topology that you see right in front of you. So this is the topology that we are going to follow during this training, throughout this training, I would say. And it is a fixed topology, and I can have a little discussion around it, right? So yeah, this is the topology that everyone of you would have access to, and it is a fixed topology that you are going to have access. So if you look at this topology, actually, this is pretty much simple topology, and also it has got everything that we needed to complete this training, right? Including DIA and everything. So if you focus on this topology, it has got the control components right there. So we have got like one vManage, one vSmart, one vBond. These all are the control components hosted in RDC, and these all control components are hosted on-prem, right? So this is on-prem deployment, and then in DC we have also got the CS router, which will be using iOS XE 17.3. So we are using version 17.3 on CS router. It's an iOS XE version, right? In DC, we have got a firewall where we have terminated internet, as well as we have terminated the MPLS in data center. We have got like two different transports, right? So one of them is internet, the other is considered as a MPLS, right? So we have got like these two transports available, right? Internet and MPLS. Then we have got remote sites. So we have got remote site 1, which is a dual CPE site. If you look at there, so when I say dual CPE, which means that you have got two different customer facing routers, and then we have got this site 2, which is a single CPE site. So when I say single CPE, which means that there would be just one VANEDGE router. Then we have got site 3. At site 3, first internet is terminating on a modem, which is doing PAT, and then from there it's terminated on your VANEDGE router. So it's kind of like broadband connection. So we are trying to illustrate an example of the broadband connectivity right here at site 3. If you look at site 1 and site 2, the internet connection is directly terminated on your CPE router. So there is no NAT device involved in between. However, at site 3, we have modified it a little so that we could also see that how SD-WAN is going to work if your VANEDGE router is sitting behind a device who is performing NAT or PAT, right? The MPLS is also terminating on a non-SD-WAN router, and then from that non-SD-WAN router, it is going towards one another VANEDGE router. So it is also a dual CPE site, but then it doesn't have the full mesh transport side connectivity, and that's where you would be implementing the TLOC extension. So this example, this topology, this site 3 is an example for the TLOC extension use case, right? So there will be a use case for the TLOC extension at site 3. So TLOC extension will get implemented at site 3. So we have got like this topology there, right? Remember, in SD-WAN or using SD-WAN, using vManage, you are going to manage only WAN facing routers, the WAN edge routers, WAN edge routers. So like at site 1, you also get a non-SD-WAN router. this non-SD-WAN router cannot be managed, or this switch cannot be managed by the SD-WAN. Or maybe at site 2 you have got non-SD-WAN. Again, it is a router, but you can also consider it as a firewall. So that cannot be managed by the vManage. Remember, only and only WAN facing routers would be your SD-WAN managed, or would be SD-WAN capable devices, right? So if your device is SD-WAN capable, then only it can be integrated with your control components. And from your vManage, you can manage all those devices. So as of today, vManage do not have capability to manage your Catalyst switches, or maybe non-SD-WAN routers, or maybe firewalls. You cannot manage them using vManage in Cisco SD-WAN. So you only going to manage your manage routers from the vManage, or using SD-WAN controller, right? So ideally in data center, you would have like core, like in DCs, you would have a core layer of switches, then you would have a distribution layer of switches, and then maybe you would have the access layer switches. Then core layer switches will further get connected with the WAN facing routers, right? So only WAN facing routers will be SD-WAN managed. And same goes with the remote sites as well. So for example, at remote sites, if you have got multiple Catalyst switches and you want a controller based networking, or you want to control those switches using controller, then use DNS center, right? So like you have got Catalyst switches at your remote sites. You want to manage them from a centralized controller, then use DNS center, right? And in data centers, you would have Nexus switches, then you have got the ACI for them. For Nexus switches, you have got the ACI. So again, you have got like different technology and different controllers for different different appliances or device families, right? So only managed routers will be managed using the SD-WAN. Okay, and that's why its name is SD-WAN, software defined wide area networking. I'm not calling it SD-LAN. Although Juniper has got like SD-WAN, as well as they have got the SD-LAN, right? So in Cisco, the SD-LAN is called basically SDA, right? That's SDA. So in Juniper, they have got SD-WAN as well as SD-LAN. But in Cisco, SD-LAN is called actually SDA. And that's where you use the DNS center, right? And DNS center is becoming famous day by day, right? It's not something which will probably go away, although they don't have any specific training for the DNS center as of today. Like SD-WAN, they have included in their one of the, they have got one of the exam based on the SD-WAN under CCNP level, right? But similar to SD-WAN exam, they don't have, like Cisco doesn't have anything for the SDA so far. Although SDA is part of their CCIE learning as well as wireless. So if you talk about the CCIE enterprise infrastructure, EI, or maybe CCIE wireless, in both, they have got some concept of the SDA. So in CCIE wireless, they have got SDA wireless, whereas in CCIE EI enterprise infrastructure, they have got the wired SDA. So that's that. So that's where these three technologies will be in use. But as of now, our focus will be only on the SD-WAN. So in SD-WAN, you are going to manage only SD-WAN capable routers, right? Also known as WAN facing routers or WAN edge routers, right? So only these routers are going to be managed by the vManage. Morley, have you got any questions, please?
Yes, just another video is being recorded. I will ask my question about this topology and the SD-WAN facing routers at the end. Okay.
Okay. So this is the lab environment, right? This is the lab. So where we have got these transports, internet, MPLS, and the multiple remote sites, and also we have got this data center, right? I'll go ahead and start with the Cisco SD-WAN solution overview. So this is traditional way of connecting your remote sites together, right? So earlier we used to have like, I mean, this is one of the example. This is not exactly like, I mean, it's not mandatory that this is that was the only way for interconnecting the remote sites traditionally. We had so many different ways for interconnecting remote sites, but yes, for now, we have taken only this scenario, right, to explain you the traditional WAN, right? So if you had like two remote sites, so ideally you had like maybe kind of MPLS, right? And also known as Metro Ethernet. So it will be depending upon like what customer is using which technology for their transport side. And then internet was also there. So it was kind of private connection, the MPLS, right? It was a private connection. So you had lane to lane connectivity, right? You had lane to lane connectivity between the remote sites over the Metro Ethernet or maybe over the MPLS, right? So yeah, I mean, this is how the remote sites were interconnected. And also for backup, we had internet connectivity, and over the internet, probably you would configure the IPsec tunnel, because that's the only way to interconnect your remote sites over the internet, right? Or maybe GRE tunnel or maybe DMVPN, whatever you would like to configure. But then traditionally, each router had its own management plane, on control plane, and data plane. So each router is having its own management plane, its own control plane, and data plane. In fact, I took this example even yesterday, right? Yesterday we had a discussion around it. Like I gave you one example of the BGP configuration changes, right? Like if you had maybe 500 sites or maybe 1000 sites, and you had MPLS or dual MPLS links across all remote sites, and one of them was primary, the other was secondary, and later if management decided to revert that or to to reverse uh, the path selection, right, then you needed to go to each and every router and to modify the policy. Why? Because each router had its own control plane. That was the reason, right? Every router was having its own control plane, right? So you needed to go to each and every site router and you needed to make the BGP changes, right? Like you needed to modify the policy in BGP. If you were using BGP, if you were using OSPF, then you would require to make the changes to OSPF or whatever routing protocol you were using. And then each router has got its own data plane, right? So each router had its dedicated management plane, its dedicated control plane, and also had its dedicated data plane, right? So this is how things were working before. Okay. Now, if it was a Metro Ethernet or probably if it was a MPLS connection, because when it comes to the MPLS, ideally you get like either layer 2 or layer 3 kind of MPLS connectivity. But in both cases, your traffic is flowing through the service provider network. So at least service provider can capture your data if it is not encrypted, if it is not sent securely, right? So in SD-WAN, what they do is even over MPLS, they are going to build the IPsec tunnel. Like IPsec is everywhere in data plane, no matter whether you have got Metro Ethernet as a transport or you have got MPLS or whatsoever. But MPLS is going to secure that, right? I mean, the IPsec, the SD-WAN is going to secure that connectivity. Now the trends and the user requirements kept on modifying, right? Now users have got different requirements nowadays. First, earlier we had only internet and MPLS as a transport, but now we have got 4G LTE as well that we can leverage as our transport, right? You can utilize even 4G LTE, and in fact, I would say that in SD-WAN we have got some route where which directly supports 4G LTE. They have compatibility. Like you can even insert the SIM card, and those routers can get connected themselves with the 4G LTE network. So the WAN is evolving. Even yesterday we had this discussion that the users have got more requirements now. The applications are moving on to cloud, and you can see so many examples for software as service, as I gave you yesterday, like Dropbox, Office 365, Box, Salesforce, Zoho, so and so. Then there is a concept of the infrastructure as service as well. Now, it is important for you to understand the meaning of these cloud terminologies, because the SaaS, software as service, or infrastructure as service, or maybe platform as service PaaS. These are many terminologies that we use when it comes to the public cloud, right? So it is important for us to understand their meanings, especially the SaaS and infrastructure as service, because Cisco SD-WAN, it does support for the integration between the on-prem routers and your SaaS-based applications, or maybe with infrastructure as service, right? Then branch sites getting direct internet access. Yes, the internet has moved on to the branches nowadays, right? Like branch user want to have access of the internet directly. So that's called DIA, direct internet access. And even yesterday, I gave you an example. I gave you one reason that why should and users should why the branch users should have the direct internet access, right? Because let's take an example of YouTube. Let's say that your branch users are accessing YouTube and they are watching videos in HD. So just imagine that how much of bandwidth they would consume. If you are still backhauling them into data center using MPLS, like if you talk about the traditional network, right? So traditionally we had that concept of backhauling the branch users into data center and then providing internet access from there. So if you follow same now, and if branch users are accessing maybe YouTube in HD, YouTube videos, right? Or maybe something else, they are using social media sites like Facebook, Instagram, and even they are watching videos there in HD, right? Now, it would be difficult for you to manage that kind of traffic, right? Because that would require more and more bandwidth. So you are consuming your MPLS unnecessarily. I mean, for unnecessary traffic. Either you will have to place the firewalls at each and every branch location, and then say that okay, you cannot access YouTube, you can't access social media, right? So you will have to restrict your branch users from accessing or from having access to those applications. So I mean, again, many organizations, they don't want to provide, or they don't want to put on the restrictions on their end users from having access to the social media accounts or maybe kind of YouTube. I have seen that, right? That some customers would come and say that no, they don't want to stop anyone from having access to those, but at same time they want the bandwidth should get utilized properly, right? So better that you provide the internet access at the branch level itself, and then in SD-WAN there is a way of doing kind of like layer 7 routing, right? So when I say layer 7 routing, which means that you can match traffic based on the applications. So when I say based on applications, which means you can match your data based on like YouTube or maybe Facebook or like Instagram or whatsoever, right? So for all those applications, you can say that even for Office 365 or Dropbox or maybe for Salesforce, right? So for all these applications, you can build a policy for your routers that send traffic directly over to the internet. Do not backhaul the traffic into the data center. So that way you would not be consuming your MPLS bandwidth, probably I would say, if there was MPLS connectivity for interconnecting branch locations to your data center locations, right? So I mean, I would have that concept later on that we will cover, and we will perform this DIA, direct internet access, manually. Like we are going to perform that practically in our labs, right? DIA. But yeah, I mean, those kind of features that you get, right? So traditional WAN challenges, yesterday we had a discussion around that, and then SDN came into the picture where you have divided, like earlier we had everything on a single device, right? It had like a control plane, management plane, everything, right? But now in SDN, you have got application layer, then control layer, and then you have got the infrastructure layer. So basically under infrastructure layer, these all are the devices, right? Which will be responsible to manage your data. Then control layer is, it's been segregated, right? So then you have got like the application. So this is how things have been divided, right? So even if you look at here, the Cisco SD-WAN, right? In Cisco SD-WAN, you have got mainly two things. I would simply say two things, right? I mean, you have got the control components, and then you have got the data plane devices. This is your data plane, right? So you have got control components, then you have got data plane components. So mainly your devices have been divided, or mainly your, in this architecture, in this whole architecture, Cisco SD-WAN architecture, all your components have been divided into two different major categories. Although I would cover them, in more details, but for now, just try to understand in this way that all your components have been divided into two different categories, the control components, and then we have got the data plane components, right? So all your routers, the WAN edge routers, These all are managed routers that you may have placed them in cloud, probably, maybe in data center, maybe in campus network, or maybe in branch, or maybe in colo. Colo is nothing, it's just co-location, right? And even Soho. So that's where you will be placing all your routers. These all are the managed routers. Then you have got transport. And as I told you that SD-WAN technology is a transport independent technology. And when I say that it is a transport independent technology, which means that it does not really depend upon the type of transport that you are using. So you can use either MPLS, you can use 4G LTE, or maybe just internet connectivity. And even within internet, you can have either internet lease line, or maybe you can simply depend upon the broadband connectivity. So it's up to you that what you want to use, right? You can utilize broadband connectivity, you can use simply internet lease line. It's all up to you, right? So this is the architecture that we are going to focus on now, right? So if you look at this architecture, mainly, in fact, if you look at this slide, right, so it looks like that this is kind of brain of the SD-WAN, right? In Cisco SD-WAN, it has got its brain, right? And altogether, these all components are working as a brain of this SD-WAN, such as vSmart is there, vManage is there, vBond is there. This vAnalytics, this is something different, right? This vAnalytics, like, it's not a mandatory component. It is good to have if you can have that, but it is not a mandatory component. So even if you take it out, like if you don't use vAnalytics, fine. There will not be any impact on your on the operations of Cisco SD-WAN. So the mandatory components would be like vManage, vSmart, and vBond, right? These all are the mandatory component. If you miss any one of them, or if any one of them is not working, then there will be a problem. Like especially a new site will not be onboarded, right? So whenever you want to onboard a new site and one of the control component is missing or is down, then you will not be onboard a new managed router, or I would call it a new site. Now, in Cisco SD-WAN, if you see there, right? So
what is the purpose of vAnalytics? Can you explain?
I will come to that point.
Sure.
So point is that I haven't started like the detailed explanation of each and every component here so far. So I will cover that. Don't worry. So point is that in Cisco SD-WAN, if you see here that we are using a distributed architecture. So when I say distributed architecture, ideally, if you take an example from Silver Peak, right? Or maybe you take an example from Velo Cloud, or maybe Juniper, maybe Meraki, or many more, right? If you take those examples, they have got a centralized, a single component or single controller doing everything, right? They have got like single controller doing everything. So when I say single controller, which means they have got a single component who is working, as probably vManage, also vBond, vSmart. Like they don't have this distributed architecture. In Cisco SD-WAN, you have got distributed architecture, but the other vendors, they have got a single component doing everything. I'm talking about the control components, right? Because in Cisco SD-WAN, we see that there are many control components, right? But others like Silver Peak, Velo Cloud, Juniper, Meraki, and many more, they have only a single controller. So they would have like all-in-one kind of controller. That single controller will have all functionalities supported. The problem with that approach could be, and in fact, I have seen that, right? I saw that in Velo Cloud. They centralized their controller went down. When that controller went down, then it affected all of their sites immediately. And that was the biggest problem that we face in such cases, right? But in Cisco SD-WAN, Cisco doesn't have that problem. Why? Because they are using the distributed architecture. So they have got different components for different functionalities or for different functions. So they have got vManage, they have got vBond, they have got vSmart. Now Cisco has also renamed them. So vManage is now Catalyst SD-WAN manager, right? As I told you. So from version 20.12 onward, the vManage would be known as Catalyst SD-WAN Manager, right? The vSmart, Catalyst SD-WAN Controller, Catalyst SD-WAN Controller. Then vBond, they call it Catalyst SD-WAN Validator. The WAN edge routers are still WAN edge routers, Catalyst SD-WAN WAN edge routers, right? But yes, the Cisco SD-WAN is been renamed as Catalyst SD-WAN now, right? So here you can see that in Cisco, basically, they are using distributed architecture. And one more thing that you need to understand, these all components are virtual components. Whether you take an example of vManage or vSmart. vBond is exception to that statement. Although we always, I personally ask customers to use vBond as a virtual device, but yes, vBond can also be a hardware. It can be a hardware. But you can also recommend your customer by saying that why are you wasting that much amount of money on hardware? Better that you go for a virtual vBond, because there is no difference in the functionality of a virtual vBond or a hardware vBond. And in fact, I would say since vBond does not participate in data plane, right? vBond does not participate in data plane. Then what is the use of having the hardware to perform the functionality of the vBond, or I would call it orchestrator? So there is no use of having it as a hardware, because you are just putting extra money. You are just investing, I would say, extra money, which is not really needed, right? So better you keep your vBond as a virtual device. But yeah, vManage, vSmart, these components are always going to be virtual components. Always keep that in remember, right? Even if you ask Cisco that, hey, I want hardware vManage, what they will do, they will send you one UCS box and will install the vManage on top of that. So there is no point of that, right? You can also do that. Like you can have your ESXi HP server, right? Or maybe Dell server on top of it, install any hypervisor such as ESXi, or maybe you can install KVM. And then on top of that, you can install vManages or vSmart. In fact, you can install them in the cloud. That's that. Right. So these all components are virtual component. Now this vAnalytics, right? I'm giving you the brief introduction of the vAnalytics. It is a SaaS-based service provided by Cisco. SaaS-based software as service. If you talk about the vAnalytics, this vAnalytics would simply perform the work of generating reports. So you can only generate interactive reports from vAnalytics. That's what it does. It does not do anything else. It doesn't like you can't use it for troubleshooting. You can't use it to make the configuration. You can't use it for doing anything, right? The only thing it does is to generate the interactive reports for yourself. So like, for example, if you need to generate the reports, like, okay, what is the bandwidth utilization for this site, or maybe which application is being used most by which branch of users or whatsoever, or organization wide. So you can have those interactive reports generated from the vAnalytics. Remember that vAnalytics will always fetch the information from vManage. So if you want vAnalytics to work, then it is mandatory for you to provide internet connectivity to the vManage. Now, in many cases, you would find that you would have a specific requirement from customer that they don't have the internet access at all, and even they don't want to provide internet access to their vManage. So if you have got such a requirement where you don't have the internet access available on your vManage, then you can't use this feature called vAnalytics, because this vAnalytics can be used only if your vManage has got the internet access. So if there is no internet access, then vAnalytics cannot be utilized. Why? Because it is a SaaS-based service provided by or offered by Cisco for their customers, right? Remember, Once again, I'm repeating my statement here that vAnalytics cannot be used to make any configuration changes. You can't perform troubleshooting. Yes, obviously it will be used for generating the interactive reports, and also you can examine that, okay, now the bandwidth utilization is hitting like almost 90% at the branch level. So it is time to upgrade the bandwidth for those branches, or maybe you want to block some applications so that you do not consume the bandwidth 100% or so, right? So those kind of things can be seen on the vAnalytics. That's it, right? So that's an optional component. It's not a mandatory component when it comes to the Cisco SD-WAN. Okay, so then you have got like managed routers, and as I told you that in Cisco SD-WAN you are going to have a secure connectivity between the branches, and that's what you have. Is look at this green lock icon. So it displays you that between the managed routers you are going to have a secure connection. Even the connection between managed router and the control components will also be a secure connection. So it's not like the information will be shared between control components and the managed routers in an insecure manner, and then anyone can read that information. No, that is not going to happen. So there will always be a secure connection get established between the control component and the managed router, which you also call as a DTLS connection, right? DTLS connection or /TLS connection, right? So you can have either DTLS or TLS. By default, there will be a DTLS connection, and both of them are secure connections. So I will explain about the DTLS or TLS in more detail later. But yeah, that kind of connectivity you would have between the managed router and the control components. And then between the managed routers, we are going to have a like kind of IPsec tunnel established, right? Just like this. And yeah, the connectivity will be secured, right? Because it is going to be an IPsec tunnel between the remote sites. So now, no matter whether you are using MPLS or internet or 4G LTE, it doesn't really matter. The connectivity between the remote sites will always be secured by IPsec, and that's what you needed, right? Earlier, we had this problem, like over the MPLS, we needed to configure get VPN to make it secure, and configuring get VPN was so difficult, right? So sometimes, or in most cases, customers were using the MPLS connection directly. I mean, they were not securing that, right? So the service provider could look into the user's traffic actually, or customer traffic, right? It was not like kind of 100% secure, right? But here in SD-WAN, like for example, if you have got a remote site, site 1, and then you have got a site 2, and there is MPLS connectivity that you have got. But again, between sites, there will be an IPsec tunnel, and that IPsec tunnel would come up automatically, right? The IPsec tunnel would come up automatically between the routers, right? So you don't really have to do anything for that. So that's the reason that you have got this, this green lock in between the remote sites. So any questions so far, like if you have got from this brief introduction?
So this branch to branch is a dynamic tunnel, or like it is fixed tunnel?
So it's up to you, right?
Okay.
Like how you want to build them. So earlier in the beginning, when this SD-WAN thing came out from Cisco, right? So we never had such option of dynamic tunnel. But now, yes, we have got the concept of dynamic tunnels, right? So we can also enable the dynamic tunnels nowadays, right? So if tunnel remains ideal, let's say for 5 minutes or maybe 10 minutes, then the tunnel will go away automatically.
So that option we need to enable.
Yes, you will have to enable that.
Hello, sir.
Yes.
Sir, exactly this the software is available in cloud actually. This is exactly HD-WAN.
Say it again, Kalpesh.
हाँ sir, this is software based ना, तो exactly is available. Where is vSmart? Where is installing this? Is a router? के what is exactly? I don't understand exactly what vSmart exactly.
Yeah, I know that you don't understand the meaning of the vSmart, you don't understand the meaning of vManage, but these all are the virtual
Where is available in
devices.
the?
This is what I told you, right? These all are. So you can have them installed either in cloud It's up to you. Also, you can have them installed on-prem. So when I say on-prem, then you will have to install them on top of either ESXi or KVM hypervisor.
Okay, okay. Okay. So later on, explain on these things, sir. Exactly what is it?
What?
Later on, you explain what is a vSmart, vManage, how can you install them?
Absolutely.
Okay.
Yesterday, we already discussed this slide. Now I'm going to go ahead and start with the architecture directly, right? So as I told you, like before, all these components have been distributed into multiple categories here, right? So if you look at
Okay.
here, this is the kind of brain of the Cisco SD-WAN, including vManage, vBond, vSmart controller, right? In data plane, you have got your data managed routers, and there will be a secure data plane connectivity between the managed routers or between remote sites, I would say, right? So there will always be an IPsec tunnel. So that's the reason that you are going to have a secure connectivity. But then to have the secure connectivity, you are relying over these control components. So it is important for you to have the connection between the manage router and the control components, right? Now remember, this vmanage is called actually management plane, right? And vbond is also known as orchestration plane, and this vsmart controller is known as control plane. I hope that now you can have more clarity on it. So vsmart controller is nothing but it is a control plane, and you know that what control plane actually does, right? So since it is going to act as a control plane, which means that these vSmart controllers would be responsible for, let's say, best path selection in Cisco SD-WAN in overlay, right? That which path is going to be best path to forward your data from one site to another site, right? So best path selection will be performed by control plane. So basically, you have offloaded the control plane here, right? So you have got a centralized control plane. So I gave you one example. So this is control plane, right? Now, yesterday I gave you one example of modifying the BGP policy, right? Especially where you had hundreds of remote branches. And I told you that if you needed to modify, let's say, a primary path and secondary path, I'm not sure that if all of you were available yesterday, maybe most of you were available, but probably one or two people were not available, were absent yesterday, right? So I would request you all to revisit that video whenever you get a chance. So this control plane or this vSmart controller, right, is going to fix that problem that we discussed yesterday. Like you had a BGP configured between PE and CE, and you had 500 sites, then you needed to go to each and every site router and you needed to make the changes manually on each and every router in BGP policy so that your primary path could be Airtel or Tata, whatsoever you wanted to configure, right? But here in Cisco SD-WAN, since you have got a centralized control plane, right, you make the changes here on vSmart and it would affect all 500 sites at the same time. So it has reduced the control plane complexity dramatically. Seriously, like you still have the same requirement. Let's say that you wanted to have probably MPLS as a primary circuit and then internet as a secondary circuit, or maybe internet as a primary and MPLS as a secondary, whatsoever, or maybe 4G LTE is also there. You don't have to go to each and every site router. No, go make the policy on vSmart controller. Say that for all these remote sites, the primary circuit is going to be internet or MPLS 4G LTE whatsoever, and it will be done. That's it. You don't have to log into each and every router at remote location. So that big pain point, right? That big problem that we had before is been fixed here by having a centralized control plane. So you are not going to have a distributed control plane now, right? So you have offloaded, like in Cisco SD-WAN architecture, the control plane has been offloaded as a centralized control plane. Now, do not think that there will not be any CPU anymore on the routers. No, even the data plane has, even the data plane has its own CPU, but also the control plane will still remain there. But the control plane functionality has been offloaded to the centralized controllers, right? Or also known as vSmart controllers. So vSmart controllers are going to work as a control plane. So most of the things will be performed by the centralized control plane. Always remember. So you will be defining, like even the route filtering. For example, there is a branch one. Let's say branch one. and you wanted to provide only some of the routes, yeah, like you wanted to perform route filtering for this branch one, you can do that on the vSmart controllers because control plane is there, right? So this control plane will define the best path, and then best path information will be given to the branch routers. So remember that even if you know, like in data center you have got the lane prefixes, in campus also you have got lane prefixes, in branch also you have got lane prefixes, at Soho you have got lane prefixes, even in cloud you have got lane prefixes. So lane prefixes will always get exchanged between the remote sites via vSmart only. So the routes will always get exchanged between the remote sites via vSmart controllers, via this control plane. Make sense? Right? And that's the reason that over this control plane, right, on this centralized controller, you can perform route filtering, best path selection, manipulation. A lot of things can be done over here. And as we move further, we will discuss more about this vSmart, right? And then you have got a management plane. This is most important, and this is also single pane of glass, actually, I would say. You are going to manage everything. You are going to manage entire SD-WAN from vManage. Like you would have a GUI access to vManage, right? There will be a GUI access that you would get to your vManage, right? And since you would have a GUI access to your vManage, and from there you will be managing the entire topology, right? So that's that. So you will be managing everything from the vManage, right? And vManage, like it is essential for you to have the GUI access to the vManage. If you lost access to vManage, then trust me, you will not be able to make changes to any device, especially to any control components. You can do that like using CLI, but that depends like how and when we manage lost access, right? Or maybe it has stopped functioning, right? So there will be some dependency over vManage, but yes, Cisco has also given you some alternatives. I will also discuss about them, don't worry, right? But vManage is a management plane. So you are going to manage everything from vManage. Like, for example, you want to make the configuration, do it from vManage. You want to perform troubleshooting, do it from vManage. You want to perform monitoring, vManage is doing that by default, right? So vManage is doing the monitoring. So you can easily see everything on vManage, which device, which component is up, which component is down, which component is participating in data plane, which component is not participating in data plane, and why, what are the problems that they are facing. Like you can see everything under the log messages, right? On vManage. Why? Because all of these managed routers will be responsible to export their information or telemetry data to the vManage, right? So that's a default behavior of this Cisco SD-WAN. Then this vBond, also known as validator, is the orchestration plane. So what is orchestration, right? So remember, this vBond is going to work as a mediator, Simply like I can compare it with Naukri.com, or maybe whatever platform you want to take as an example for finding jobs outside India, inside India. There are so many different platforms available, right, that you can use for getting a job. So what happens over there is that we as an employee, right, we always create our profile over there whenever we are hunting for a job, right? And we update that and we say that yes, we are available to give the interviews, and we are ready to switch our job. And then the employers, right, I'm not talking about the employee because employees have already registered themselves on this portal, right? And then employer will also get themselves registered to this portal, right? And then employer would obtain the employee information, right, or the resource information from this portal, and then employer will make a call to this resource, right, that hey, are you willing to change your job? Are you looking for a job? First they will get that confirmation, and then so basically this portal is working as a mediator, and that's exactly this vBond, this orchestrator does, right? So that's the exact use case of the orchestration plane. Questions?
I have one question here.
Mm-hmm.
So branch A and B wants to talk. So branch there is no control plane in the edge routers.
Mm-hmm.
So again it is going to a controller, and again coming back to branch B. So do you face any latency issue? Again it is
No,
going back to controller.
now there are two things that you have mixed up, right? The control plane is is always used only for exchanging the control plane information, not the data plane. Correct?
Yes.
User traffic will always go through the data plane.
Yeah.
Correct? So
Right.
whenever I say that the control plane the control plane functionality is been offloaded, which means that only route information will get exchanged between the branch and between the SD-WAN branches via controllers. But then they have got the direct IPsec tunnel from where the user traffic will go directly from one side to another side. So remember that your user data will never ever go through any of the control component.
So this here actually this routing decision will take edge router itself. You mean to say?
Yeah, absolutely. Because the data plane also responsible to maintain the FAB, right? Forwarding information
Yes.
base. So each
Yeah.
data
That's
plane
what my question. Yeah. Okay.
would have its FAB table, right? So the routing decision will be made at the router itself. But that route information will be given by the vSmart to the
Got
VNS
it.
router, best path information, right?
Yeah. Kind
Makes
of
sense?
DMVPN. Yeah. Yeah.
And and one more thing that you need to understand, that when I say that control plane is being offloaded, don't think that there is no control plane available on the router anymore. No,
That is
the
what like
control plane
they
is
are
still out
stable.
there.
Yeah.
Even the management plane is there. You can have the access of this router using SSH, right? You can still access those routers. So management plane is there. Even the control plane is also there, because as I told you, the OMP overlay management protocol, right? So the vSmart will provide the best path information through the OMP updates to the VANEDGE router. So VANEDGE router is also going to store that information somewhere. So which means that it has got the OMP database, right? And I would say that yes, control plane is still out there, but since the best path selection is performed by the vSmart, so I would say that control plane is being offloaded, but not everything. Now what about, like, I'll give you one more example here, that why control plane is still exist on the VANEDGE routers. So let's assume that there was a branch router and it was connected to a layer 3 switch now, right, towards the lane side,
Yeah.
right? This is lane side. Now you are using maybe OSPF there, or maybe you are using BGP. So BGP has to be implemented here, right? On this VANEDGE router. So if BGP is running there, so how can we say that control plane does not exist on this router? So control plane does still exist, but in SD-WAN, right? In regards with SD-WAN, the best path selection is performed by vSmart, and that's the reason we call it like control plane is being offloaded in respect to the SD-WAN. But to support the traditional routing protocol, like that support is still provided by the SD-WAN VANEDGE routers. Yeah, still it is there. And you will be probably like in future, you're going to learn about the OMP and all those protocols. And then you will be doing the redistribution between OMP and BGP, or maybe OSPF, OMP, whatsoever, right? So you will be doing those kind of redistributions as well, so that your routes that is coming from the overlay can be given to the lane side devices or to the non-SD-WAN devices. Okay. And even in branches, you can also implement the VRRP. That feature is also out there. So that is still supported. So a lot of things like that we were using traditionally are still supported by the SD-WAN. All right, now let's start talking about each and every individual component, right? Like, first of all, we're going to talk about the management plane, also known as vManage. So this vManage is a management plane. Remember that this is going to be a single pane of glass for day 0, day 1, and day 2 operation. Now, what is day 0? Day 0 basically is all about the design, right? Day 1 is all about the implementation. And day 2 is always, is always kind of like providing the support. Right? So all those things can be performed on the vManage. Like, you can create a design. Like, yeah, I mean, that feature is available. You don't really have to draw the diagram in Visio. You can draw your diagram on vManage itself. And whenever somebody joins in your team, they can simply look at that diagram, and then they can get an idea that how connectivity is working between the remote sites and data center, or maybe if you have got some regional sites, regional hubs, whatever, right? So you can have that design created. You will be doing implementation from the vManage itself, because all the templates will be created on vManage. And then also you will be doing monitoring from the vManage. Like, obviously you are doing the day 2 operations, like even the troubleshooting can be done or will be performed from the vManage. I would make one statement here. you can do everything from the vManage. Even if you want to have the CLI access of the devices, you can take it from the vManage. You don't really have to open up the putty and then access the devices separately. No, just get the access to vManage, log in onto vManage, and then even you can have the CLI access of the all other components onto the vManage. Right? vManage gives you that functionality as well. So you are going to perform everything from the vManage. Now the multi-tenancy is also supported here by vManage, and it was important to get that multi-tenancy feature supported by vManage. You know why? Because this vManage is that component that that uses a lot of or that utilizes a lot of hardware. Like it would require minimum. Let me give you the minimum requirement for the vManage deployment: the 16 virtual CPU, 32 GB of RAM. Then you have got a requirement of one storage disk for 20 GB, another storage disk minimum 500 GB, and all of them have to be SSD. So for vManage, you would always require two different disks, one for OS installation, and the other disk would be needed for the storage purposes. And that is minimum requirement would be 500 GB, but it is good to have like 1 TB or maybe 2 TB or so, right? And your disk should be the solid state disk, right? SSD. That is the minimum requirement for deploying the vManage. Now just imagine if a customer was having like 8 to 10 sites, small customer, why would they move on to vManage then? I mean, why would they move on to the SD-WAN? Because the cost of the vManage itself is so high. Just try to get those resources in cloud, and then you would see that how much bill you get for the complete year. So why would they move on to the SD-WAN then? Because if cost goes high, then there is no advantage of having the SD-WAN in place, right? So that's where the multi-tenancy came into the picture. So the MSPs, like for MSPs, this is very useful feature. So when I say MSP, which means we are talking about the managed service providers. I'll give you a couple of examples, of the organizations that are providing or that are working as a MSP, such as BT, even the Airtel, Tata, right, Orange, AT&T, Cisco itself, right, Accenture, HCL. These all are the MSPs, right, managed service providers. So they do provide managed services to their customer. Now, sometimes whenever customer comes to any MSP and they say that, okay, we are a small customer and we don't have that much amount of money. So is there a way to cut the cost for us? So Cisco or maybe any MSP will give them an option of the multi-tenancy, the vManage deployed in multi-tenancy mode. Like you would not have your standalone or your dedicated vManage deployed. You would be having an access to the vManage, which is shared with the other customers as well, right?
But MSC also we have to pay, right?
Yeah, absolutely. Absolutely. You are purchasing managed services, then why you would not
That's
be
what I'm
paying to
saying. It
them?
is also comes under cost, right?
Yeah, absolutely. But then they will be managing everything on your behalf, na? So you can get rid
Yeah,
of your internal IT teams and everyone, right? So then jobs, there will be you would say then that there is a layoff, right, happening within that organization, but there will not be any layoff. Why? Because if that layoff is happening at the end of customer, then at least the provider will be hiring for them, isn't? So I mean,
yeah.
it's like it's a business, right? It's a business. Okay, so the multi-tenancy is supported by the vManage, which means that you can leverage your vManage for multiple customers, right? So yeah, then centralized provisioning, right? It does support the centralized provisioning. As I told you, everything is going to be performed by vManage, right? The policies, the configuration templates, everything will be created on vManage. Even the troubleshooting monitoring will be done on the vManage. You want to perform software upgrade for any of the component, the software upgrade will be done by the vManage or from the vManage. You don't really have to go to each and every component, and then you will not be required. You will not require to upgrade them individually, right? No, you just have to go to your vManage, and from there only you can upgrade all of your components. So the software upgrade, and on top of that, this RBAC, role-based access control is also supported, like maybe if we are working as a MSP, managed service provider, even if customer is managing its network by their own, but they will ideally have multiple teams available, right? Like there will be one team who is ideally doing monitoring, and nowadays we call them layer 1.5, right? Layer 1, L 1.5 engineers, right? Then you have got L2 engineers, L3 engineers. Then all these level of engineers would have different level of access, and that can be achieved by the help of RBAC, role based access control. Like for example, there is a team whom you want to provide an access to shut down and unshut the interfaces, and everything else should be read only, right? Then L2 team would have like more access, like you want to provide them access access level up to like maybe attaching devices to the template, detaching devices from the template, making some changes to the configuration templates but not to the policies. Then you would have the level 3 of level 3 engineers, a team of level 3 engineers. Then the team, to that team you would provide kind of like full access, read write access to everything, right? Probably, right? So again, you have got the role based access control kind of feature that you can use, right? So you can create like groups, and then different groups, and then you can provide different level of access, and like the network engineers, right? Part of different teams would have different level of access, and that's RBAC, right? Remember that the vManage is going to support for REST API as well as netconf is supported. So netconf is nothing but it is an advanced version of the SNMP. So what Cisco has done, like this vManage is also known as NMS, Network Management System. And you know that whether you talk about this vManage or any NMS, maybe you were having before NMS like QRadar or maybe SolarWind, right? Or maybe there are many other NMS available out there in the market, right? Ideally, you would see that NMS will work on the SNMP, like they will use SNMP to pull the information from the other devices participating in your network, or in your net available in your network, and sometimes they will also push the configuration. That's what NMS does, right? Sometimes you would have a NMS who is just doing the monitoring, right? So we should give it an information, or like you must have heard that the SNMP community was set up as a read only RO, but sometimes read write, which means that the NMS wants to push the configuration onto devices. So it depends, right? Like if you are integrating everything to your AlgoSec, let's say AlgoSec is kind of again NMS, right? Which helps you to monitor your network. And AlgoSec is a very, very strong tool actually, which can also push the changes to your network devices based on the requirement, right? So you can also tell, like nowadays the AlgoSec is very, very, I would say intelligent tool. Now it has become, even if you tell your AlgoSec like what kind of what access you want, and AlgoSec would find the path for yourself, and on all the transit devices it can make the changes by its own. But let's let's not talk about the AlgoSec. Point is that I wanted to talk about the NMS, and NMS can talk to the other components using like SNMP. Like earlier we were using SNMP, right? But now netconf is being used. So now we are using netconf for the purpose of integrating, or for the purpose of communication between the NMS and all other components. So remember that vManage is going to talk with vBond, with vSmart, even with the vManage router using netconf. So there will not be any use of SNMP. There will not be any use of SNMP. Why? Because vManage is going to utilize, or vManage is utilizing netconf for that purpose. So again, netconf is, if you talk about the netconf, right? Netconf is an advanced version of the SNMP. Say it again.
It is by default feature, or we need to enable this?
It's a default feature of the SD-WAN, Cisco SD-WAN, that by default it will be using, like vManage will be using netconf for pulling the information from other components, and even to push the configuration onto other components. And it's a default protocol. You cannot modify that. Like if you want, like I don't want to use netconf, I want to use SNMP. No, you can't do that. But yes, there is one more thing that is available. For example, if you have got some third party third party NMS. Let's say that is still out there, right? And you want to integrate all of your network devices with that third party NMS. And that's where you would be needing SNMP implemented, right? Because without configuring SNMP communities, it is not possible for you to perform the integration between third party NMS and all these control components. So you can still put down the SNMP communities there, so that the third party NMS can still talk to your SD-WAN components, whether it is vSmart or vBond or it is vManage or your VANAGE router. So SNMP communities can still be implemented, so that your third party NMS can talk to all your SD-WAN components. And I'm talking about that third party NMS which do not support the netconf, because if third party tool or third party NMS is supporting netconf, then again there is no need of implementing SNMP. But my point is that it is still supported. Like if I want, I can implement SNMP community on any of these components, whether that is vManage or vBond, vSmart or the VANAGE router. Okay, so SNMP is still supported. So netconf will be used by vManage automatically, and we cannot modify that. Like vManage is always going to use netconf for pulling up the information from other components and also to push the configuration, right? Now REST API is also supported, and now it is very useful feature for the purpose of automation. Like I'll give you one example, and this is what we did actually for one of our customer. What we did was, like, they had subscription to the ServiceNow. Now what they wanted was, like, what customer wanted, that if vManage gets a event, for example, of any one of the OMP peering goes down, or maybe, you know, let me give you one small example. If any of the interface of the VANAGE router goes down, let's say, so on VANAGE router, if any interface goes down, it will be exporting that telemetry data over to vManage, right? So vManage is supposed to receive the event coming from the branch routers in its event bucket. That interface went down, correct? Now what I wanted, or what customer wanted, that if this event occurs on vManage, if it comes up on vManage, then this service now should create a ticket automatically, and it should assign the ticket to that specific DL, distributed list, right? And that's something that service now would be doing that. So what we did using REST API, because vManage is supporting the REST API, it supports REST API. So using REST API, we integrated the ServiceNow box with vManage. We said that in every 5 minutes, let's say, I don't remember exactly the timer, but I'm just giving you one hypothetical value, that in every 5 minutes, ServiceNow will fetch, like we created one script here, that in every 5 minutes, we will fetch the event bucket from vManage. Now in that event bucket, if it find, let's say, the interface went down, then against that, ServiceNow will create a ticket automatically and will assign that to the distribution list automatically. Then after some time, if you get the event, let's say interface came back up, then the ticket should be updated automatically, that now interface came back up. So that kind of integration between ServiceNow, which is a third party tool again, right? Ticketing tool or whatever it is, monitoring tool, whatever you would like to call it, you call it, right? That was integrated with vManage using REST API. So using REST API, you can integrate any of your third party app with your vManage. So REST API is supported by vManage. Does that make sense to all of you?
Yeah, with the help of REST API, we can generate some reports as well, right? Like
you can generate reports, you can create template, you can attach devices, you can detach devices, you can create feature template, create device template, and then put the variables. You do whatever you would like to perform. Even performing upgradation can be done using REST API. Lot of things can be automated using REST API. Okay, but again, that is not going to be part of this training, because that is all about the automation. There is nothing to do with the SD-WAN. I will show you that which all REST APIs are supported by vManage. We can also try to run a couple of them, right? But the scripts will not be created over here. Highly resilient. Why? Remember that Viptela operating system, right, is using the or is built based on Linux operating system. And that's the reason that we call it highly resilient. Remember that Viptela OS is a Linux-based operating system. Murli, I will put you on mute if you don't have the question because I'm getting some background noise. You are probably using your keyboard. So Viptela OS is using, is built using Linux, right? Linux operating system. So even you can use the Linux commands if you needed them to get executed, right, on vmanage. So whenever you talk about the Viptela OS, which means it's a Linux based operating system. If I'm talking, because in Cisco SD-WAN you have got like two different operating system. One is called Viptela OS. The other one is IOSXE. IOSXE is used by Cisco edge routers only. Cisco edge routers only. None of the controller like vmanage or maybe vbond, vsmart, none of them uses IOSXE. So IOSXE is used by Cisco edge routers only, or Cisco WAN edge routers only. But Viptela OS is used by all of your control components like vmanage, vsmart, and vbond. In fact, if you are using a Viptela edge router, that will also use the Viptela operating system. So Viptela only had Viptela operating system. Later, when Cisco acquired Viptela, thereafter Cisco added their own, they had the support for SD-WAN on their own devices, on their own routers, and that's where they added the SD-WAN capability to the IOSXE. So this IOSXE with SD-WAN capability will be supported by Cisco WAN edge routers, such as Cisco, ISR 4K, ISR 1K. Then you have got new Catalyst series of routers nowadays, right? So Cisco launched the whole new brand new series of routers called Catalyst series of routers. So I would, show you that which all different series of routers are going to support the SD-WAN, right? So I'll give you that complete information. Don't worry, because later on, like as of now, I'm covering vmanage, but later I will cover the WAN edge routers as well independently.
So can we mix up like a Viptela and Cisco devices in branch level? Okay.
Yeah, absolutely. So at some sites you can probably install the routers from Viptela. At some sites you can install the routers from Cisco. That is absolutely fine. Okay. Right? The controllers will always be using the Viptela operating system. There is no other option available. Right? So vmanage is always going to be a VM, virtual machine, that can be hosted inside cloud, public cloud, or maybe on-prem on top of ESXi or maybe KVM. Right? Now let's talk about the control plane.
Sorry. No, I have no questions.
Okay. Because see, if there is no background noise, I don't have any problem. But if there is a background noise, like you are coughing, or maybe something else is happening at your end, then
no, by mistake it got unmuted.
Yourself mute it if you don't have the question. Okay, no problem. I'm just repeating my statement that I made yesterday, right? Because see, later on you will be watching these videos, and if there is a background noise, then it will be you might feel annoying while watching videos later on. Okay. So control plane, as I told you, vSmart, known as, vSmarts are known as the control plane. Now you are going to have a centralized control plane, right? You have got a centralized control plane. You have got offloaded, you have got your control plane offloaded from your WAN edge router to this vSmart controllers. So remember that the vSmart controllers will facilitate the fabric discovery. Now, what is fabric? Can anyone explain it to me?
Can I jump in?
Yep, absolutely. Anyone.
Fabric can be defined as your switches and your cabling of your networking system that you're operating is one definition.
Yeah, so I would say fabric is nothing, but it is a virtual network, right? Or virtual networking. Correct. I mean, in short, I can simply call it virtual networking. Correct. Now, it's everywhere. Even if you are using SD-WAN, then virtual networking is there. In SDA, virtual networking is there. In ACI also there is a virtual networking, right? So virtual network is your fabric actually. you know what happens is that all your branches will be connected to each other, but virtually. They're not interconnected physically, right? Maybe you are connected through the broadband, but that's fine. Maybe you're connected, your transport is MPLS, right? But using virtual network, all these branches will be interconnected, especially using the IPsec tunnel. In data plane, you are going to build the IPsec tunnel. And that discovery can be performed by the help of vSmart controllers only. If vSmart is not there, then forget about this discovery. You know why? Because for an example, there is a campus router and then there is a branch router. If they want to build the IPsec tunnel or data plane connectivity, let's say, then they need to exchange some sort of information between each other, such as their physical WAN facing interface information, maybe pre-shared key, or they have to perform the key exchange and everything, right? That all would happen via vSmarts only in the form of OMP updates. The OMP protocol will always be running between the WAN edge router and the vSmart controllers, which is also known as control plane, right? So OMP will be running there. So if OMP is not running there, or maybe if vSmarts are not running, then fabric discovery cannot be performed, right? And as I told you, disseminate the control plane information between the WAN edge router. So control plane information is going to be get exchanged between the WAN edge router, between remote sites via vSmart only. Not only that, but also let's say you created some sort of let's say the policy, right, on vManage. Let's say you said that YouTube traffic should go directly over the internet for the WAN edge router. So policy will be created on vManage. vManage will give it to vSmart. Now vSmart will see that, okay, this policy belongs to data plane devices, and therefore I should forward this policy to the WAN edge routers. So vSmart would provide or will forward that policy over to the WAN edge router. And then WAN edge router would be responsible to deploy or to implement that policy, right? But also the vSmart controllers will be responsible to implement control policies, right? Such as if you wanted to perform route filtering, you wanted to modify the topology, like if you have got like multiple options like full mesh topology between the WAN edge routers. I'm talking about the data plane connectivity between remote sites. So if you wanted to have like full mesh or maybe partial mesh, that can be controlled by you can perform path manipulation for best path selection. Like for example, you have got like two different transports from branch to reach your campus. You might reach your campus from branch using internet, using MPLS, using 4G. Now you wanted to prefer one of them. So that kind of policies can be built on vSmart controllers. Those policies will be implemented by vSmart controllers. And then that information will be given to the WAN edge router by the vSmart. Hey, this is the best path for you to reach campus, right? So those policies will be implemented, like route filtering, path manipulation will be implemented by vSmart. But any data plane policy where you say, like if this is source IP, destination IP, then traffic should go through this way, or maybe YouTube traffic should go directly over the internet, or Facebook traffic. So that comes under the data plane policy or application aware routing policies. So remember that data plane policies or app aware routing policies will be forwarded or will be distributed by vSmart among your WAN edge routers. Will not be implemented by vSmart because those are data plane policies. Remember, the policies will always be like two different types of policies: the data plane policies and control plane policies. The control plane policies will always be implemented by control plane, which is your vSmart. The data plane device policies will always be implemented by data plane devices, which are your WAN edge routers. But who is giving the data plane policy to the WAN edge router? It's vSmart. You will be creating them on vManage. vManage will give it to vSmart. vSmart is smart enough to understand that this is data plane policy and that should be given to the or distributed to the WAN edge routers. So that vSmart will be doing, to perform probably app aware routing or maybe some other data plane policies, right? It dramatically reduces the control plane complexity. You know why? I gave you one example yesterday, right? That if you have got like maybe 500 sites and you were running BGP and you needed to update or you needed to modify primary secondary path, then you need to log in or you needed to log into each and every branch router and to modify the BGP policy so that you could modify the primary or secondary path, right? But in SD-WAN, you just have to go to your vSmart controller, update the policy there, and then vSmart will provide the best path information to the managed router dynamically. So you don't really have to log into each and every router, right? So that's what it will perform, and that's how it would dramatically reduce the control plane complexity. Does that make sense to all of you?
Yes.
Okay. Highly resilient. Why? Because it is also using a Linux based operating system, right? It is using Viptela operating system, which is a Linux based, and so it will be highly resilient, right? So all of the control components, including vBond, will be using Linux based operating system, right? So this is vSmart. This is control plane. I hope that everyone got this information. So in short, let me give you one more example. Let's say in data center, you have got the lane prefix. In campus also, you have got lane prefix. If they want to exchange their lane prefix information, so then they will have to provide that information to the vSmart in the form of OMP updates. Same, campus routers will be providing that information to the vSmart controllers or control plane in the form of OMP updates. Then vSmart controller will perform the best path selection, and then by default, vSmart controller is going to work as a route reflectors in BGP. Like if they receive the lane prefix information from one of their OMP peer or from one of the site, then it would be advertised to others, right? So that's how the lane prefix information will get exchanged between data center and then campus, right? So any control plane information will get exchanged between the remote sites via vSmart only, and that's why we call it route reflector, because that's what route reflector does in BGP. Right. So if anybody understands route reflectors functionality in BGP, they can easily compare that with the vSmart controllers here in Cisco SD-WAN. Right. So the default behavior of the vSmart controller is to work as a route reflector over here. Once lane information, once routes have got exchanged between the remote sites, now their lane users can also talk to each other. But then user traffic will be going through the IPsec tunnel, which was directly built between the managed routers. So user traffic will not be going to any of your control component. It's just that control plane information will get exchanged between the remote sites via vSmart controllers. Orchestration plane. As I told you that it is going to work as a mediator, right? This vBond. Now this vBond, also known as orchestration plane, I would call it first point of authentication for every component participating in this architecture. So when you power on your vSmart, you power on your vManage, you power on your managed router. Whenever you power on any component, the very first thing it does is to talk to. So vBond is going to work as a first point of authentication, and it basically works based on the whitelisting model. You know what? Whenever you power on the managed router, let's say a branch router was powered on. So first it must go to vBond. Now what does this mean? This means that your managed router must have an IP address of the vBond, an IP address of the vBond. Now there are two ways to do so. Either you take the console access of the managed router or of the branch router and configure the vBond IP address manually, that this is the vBond IP address, or you automate that. And when you automate that thing, then you call it ZTP, zero touch provisioning. I'm not moving into zero touch now. I'll simply say that, okay, I went and took the console access of the managed router at the remote location or branch at branch level. I took the console access, and then we simply provided the IP address of the vBond. Remember that managed router can talk to vBond only when it has got an IP address of the vBond. So it is important for us provide the IP address of the of the vBond to our managed router. That is so important, right? Without providing the IP address of the vBond, managed router will never ever reach out to the vBond, right? And that's the only reason that vBond must have a static public IP configured. If you want your managed routers sitting behind internet should talk to vBond. So if let's say there is a branch router, right? It has got only internet access. If it has got only internet access and if it wants to reach out to vBond, then it should be a public IP address, correct? Remember that in this whole architecture of the Cisco SD-WAN, vBond is the only component, right? vBond is the only component must have a static public IP address configured. If it is sitting behind a NAT device, then make sure that you configure the static NAT, also known as one-on-one NAT. So configuring one-on-one NAT is really important. Now
Is there
we
any
manage.
specific port number to
Sorry.
communicate? Is there any specific port number to communicate from the branch to vBond? Why? Because some organizations may have some firewalls
Yeah,
in between.
absolutely. I will come to that point as well when I start with the TLS or DTLS, right? So then I will
Okay.
discuss about the port numbers, that which all port numbers are being used by the devices to communicate with each other, right? So there is just not one port number. I mean, I will not say there is just like we have just got only one port number. There is a set of port numbers that needs to be allowed onto the firewalls. So the vBond must have a static public IP address, right? That is mandatory. Others like vManage, vSmart, you can have them installed behind a NAT device. That is okay. You can have them installed behind a NAT device who is let's say who is doing a PAT kind of thing. That is okay. But it is good to have the public IP address configured on each and every component. It is good. I'm not saying it is mandatory, but it is good to have that. But for vBond, it is mandatory. Like at least vBond must have a static public IP address. That is mandatory. Yeah, I mean, there could be a situation where, let's say, you want to say that there is a customer who never uses internet. Then if customer is not using the internet, then why would you configure the public IP address of the vBond on the vBond, right? You just go ahead and configure the private IP address on the vBond and then provide that private IP address onto your managed router, and then make sure that yes, your managed router can reach out to that private IP address using your transport. Maybe you will be using MPLS in that case. So you should have the routing in place so that your managed routers can talk to vBond using that private IP. So it's all about the reachability, because over the internet, only public IPs are allowed. So if you want your managed routers to talk to vBond over the internet, then yeah, it will be mandatory then to allocate the public IP address onto your vBond. Remember that it also supports the NAT-T feature, and that is very critical. Why I'm saying critical, which means when I say critical, it means that it is not harming your SD-WAN. Point is that having support for NAT-T is really critical to make this work, to make this Cisco SD-WAN thing work. If you do not have NAT-T supported, like let's assume that there was no NAT-T support for, there was no support for the NAT-T by the vBond, then SD-WAN would not work as it is expected to do, right? I mean, it will not be functioning then. Trust me, right? Especially where you have got like broadband connectivity and all that. So it will not be functioning then as per the requirements, right? So point is that it is mandatory, right, for vBond to support NAT-T, and we don't really have to enable anything for that. The NAT-T feature is by default enabled. Remember, it is by default enabled on vBond. vBond does support, or it has support for the NAT-T by default. You don't do anything for that. Okay. So NAT traversal, and I believe that all of you are already aware with that terminology, because whenever we talk about the site-to-site tunnel or lane-to-lane IPsec VPN between the remote sites, then without having the understanding of NAT-T, we cannot even think of establishing the IPsec tunnel. I mean, it is important, especially where you have got the firewalls, right? I believe that you remember that port number ISACAMP UDP 500 and then 4500. You still remember that, right? NAT-T functionality, right? So same function, same function is supported by vBond. Like vBond understand, like it can easily identify if device is coming to vBond after NAT or it's coming directly. If managed router reached out to vBond, let's say there was a NAT happened somewhere, right? And then it reached out to vBond. vBond will identify that, and then vBond will inform it back to this device that, hey, you are sitting behind a NAT, and this is your actual IP address and the port. So this is what vBond will be doing in this case, because vBond has got a feature called NAT-T. By leveraging that, it can easily identify that who is coming after NAT, or if the device is coming to me directly. Remember that it also has a list of control components. Like vBond will have a permanent connection with vManage, vSmarts, all of the vSmarts. So it will have the controller list. It will have the controller list. vBond knows that who all are the controllers. Who all are controllers. Therefore, whenever a managed router goes to vBond, let's say, so first vBond will authenticate the managed router. We'll check a couple of parameters. I'm not talking about those parameters now because I'm not moving into the authentication as of now. But it will check like a couple of parameters. Same managed router will check the couple of parameters of the vBond as well. If they authenticate each other, let's say authentication was successful between vBond, between orchestrator and the managed router, then you know what vBond does? It will distribute, or it will provide the controller list to the WAN edge router. And that's how the WAN edge router would get the controller list, or it will get the IP addresses of the vSmart, of the vManage, and then WAN edge router will start talking to vSmart and also will start talking to vManage. I mean to say, then WAN edge router would initiate a connection with vSmart controller as well as with the vManage. Does that make sense? And remember that vBond will always have a list of valid WAN edge router. So it is not like anyone, like any WAN edge router can go to vBond and can get authenticated. No, the vBond will always have a list of valid WAN edge routers, like their chassis number and then serial number, right? It will, you know, vBond will always have that list of valid WAN edge routers. So if WAN edge router is trying to authenticate with the vBond, with the orchestrator, since orchestrator is already maintaining the list of valid WAN edge routers, so it will always validate their chassis number and the serial number. And based on that only, like if WAN edge router came with a valid chassis number and valid serial number, then only vBond will authenticate that WAN edge router, else the connection will not be established, and then vBond will not be providing the list of the controllers, right? And again, it has got the highly resilient, like it is highly resilient. Why? Because again, it is using viptela operating system. Now remember, this vBond can be a hardware as well. You know, it's a viptela edge router. Actually, it's a viptela edge router. vBond is not a separate device. It does not use any different operating system. Yes, for vManage we have got a different operating system. For vSmart we have got a different operating system. But vBond is your vEdge router. It's a vEdge router, viptela edge router, which uses a viptela operating system used for the routers itself, for the WAN edge routers itself. It's a WAN edge router itself using viptela operating system. What you do is you just go to that router and you simply tell that router that, hey, you're not supposed to work as a router anymore. Just start working as an orchestrator, as a vBond. So we just have to execute one simple command. You go execute that command, and that's how you convert a WAN edge router into a vBond. Now, since your WAN edge router can be a virtual, also can be a hardware. Therefore, vBond can be virtual, can also be a hardware, because vBond is not a separate device. It does not use any separate operating system. No, it is a vEdge router. Now, vEdge router can be a it can be virtual. It can also be a physical router, and that's the reason that I made that statement, that this is one exception, right? The vBond can be virtual, can be hardware. But why would you go for a hardware vBond? Why would you use a hardware device for working as an orchestrator? No user traffic will ever travel through vBond. No user traffic will be processed by the vBond. So why would you go for the hardware device then? So, you know, like tell your customer that, hey, use the virtual vBond, because we are not taking the user traffic through the vBond. So what is the point of using the hardware vBond then? So that's about the Cisco vBond. So that these are the roles and responsibilities performed by any component whenever you power on them, whether it is vSmart, vManage, or a WAN edge router. All these components are going to talk with vBond. That's the first point of authentication. So it is a first point of authentication for all of the components, not just for a single component. And one more thing, in few cases, you know, there is one exception. Like ideally we say that vBond will provide the controller list. vBond will provide a controller list to the WAN edge routers. But in some cases, it can also provide the list of, or it can also provide the information of WAN edge router, of WAN edge routers to the controllers as well. Like whenever a WAN edge router goes to vBond, and let's say vBond authenticated that WAN edge router successfully, then vBond can also provide that information to vManage and vSmart that, hey, this is one of the WAN edge router is trying to connect with you. But that is not going to happen every time. That is not going to happen in all cases. No, there is one exception where it would happen, where, you know, vBond do not only provide the controller list to the WAN edge router upon successful authentication, but also it will provide it will also provide the WAN edge router information to the control components, to vManage and the vSmart, so that they can also initiate the connection with the WAN edge router. But we have got some specific you know, use cases for that. I will discuss them later, not now. But yeah, I mean, this is what vBond is doing, right? So I hope that everyone is now comfortable with the roles and responsibilities performed by the vBond, right? So vBond is simply working as a mediator between managed router and other control components like vManage and the vSmart. One more thing, the managed router would have the temporary connection with the vBond. Like once vBond has provided the controller list to the managed routers, thereafter this temporary connection will go down automatically. But between vBond and vManage, and between vBond and the vSmart, or even between vManage and the vSmart, there will be a permanent connection. In fact, between managed router and vSmart, managed router and the vManage, there will be a permanent connection. The only connection between managed router and the vBond will be a temporary connection. Right? Once vBond provides the controller list back to managed router, then this connection will go down. It will be teared down automatically. That's how it works. Any questions?
Yeah, from WAN edge, who will be the front end? I mean, like from the SD-WAN fabric, like who is really going to pair with the WAN edges?
So this is what I told you, right? So from a managed router perspective, it will have a permanent connection with vSmart control connection and the management plane connection with the vManage, and then IPsec tunnel between the managed router. The user traffic will directly exchange between the managed router in the form of IPsec tunnel, right? Through these IPsec tunnel, but any control plane information will get exchanged between the routers via vSmart controllers only. And then if you are making any configuration onto your managed router from vManage, then vManage will be pushing that information to the managed router using this connection.
Okay, that connection is netconf.
Inside that tunnel, yes.
Yeah. Okay. Okay. There will be an IPsec from WAN edge to the vSmart and vManage as well.
Yeah, absolutely.
Okay. But okay, on IPsec the netconf will run.
No, there is no IPsec tunnel between vManage and the managed router. The IPsec tunnel is between the managed routers only. Right?
Okay.
There is a
then what
DTLS.
What is
There is a DTLS tunnel
okay.
between the vManage and the managed router, and there is a DTLS tunnel between vSmart and the managed router.
Okay. 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 So DTLS is the I mean, like the medium.
Yes. I mean, it is also a secure tunnel.
Thanks.
So what about the OMP?
The OMP will be running between vSmart and the managed router and between vSmarts. And OMP also runs inside the DTLS tunnel, which is a secure tunnel.
Okay. And netconf will be running between vManage and the VH router, right?
Not only there, but between vManage. I mean, any router, if vManage is pushing or pulling information from any of the component, it will be using netconf for that.
And vSmart also uses netconf?
If vSmart is pulling some information from vBond or from vManage, it will be using netconf. But if vSmart is exchanging some information with the managed routers, it does in the form of OMP.
Okay. Okay.
Anybody else?
Yeah, this vBond actually mediated for like only managed routers, right? Not for vManage and vControl. vSmart?
Which tunnel, sir?
No, vBond is only mediated for edge routers. Not for
every device. This is what I stated, Gangadhar. Right?
Yeah, I have one doubt here.
That this is the first point of authentication for each and every component, no matter whether it is a managed router or vManage or a vSmart. So, for example, if like what ideally there is a sequence of onboarding your components. Like first you onboard the vManage, then you onboard the vBond, second number, and third you start onboarding the vSmart. So let's say vSmart went to vBond, got authenticated with vBond, then vBond will provide the vManage information to the vSmart and the vSmart information to the vManage, so that vManage and the vSmart can talk to each other. They can have a connection established between each other, right? So there is a sequence of onboarding the components. Once all of your control components are onboarded, then you start with the managed router. Make sense?
Okay, that is what my question. What is the sequence you told that? Okay.
Anybody else? No?
Hello, sir. Sorry, have you finished the general questions regarding orchestration plane?
You go ahead. You ask your questions.
Okay. So this is question number 1. Relates to the topology in the lecture. With the given topology, since we are only interested in the routers facing the WAN, which devices should be launched in the virtual environment, since we're only concerned about the bandwidth where two people may be logged on at the same time, accessing their instance of the lab topology, would it be affected by the bandwidth?
Something that I probably would say that from a lab perspective, each one of you having access to a different board, you do whatever you want to perform in your lab. Others will perform whatever they want to perform in their own lab. And there is enough bandwidth available at our end, probably, right? But again, that is something that you might want to raise this question in front of the management, because I do not manage those labs. I can help you if something is not working in that lab, like maybe SD-WAN is not working, but in backend, how the lab is constructed, that is something managed by the other team.
Could you bring up the topology of the lab, please? So each site has got vManage, vBond, vSmart. So if you access the lab via SSH from outside of the I-MEDITA, now you have to have those components active and up. With your routers, you've said that they must be up. So if you are doing the lab between site 1 and site 2, you would just focus on those two sites and not have active all of the lab topology? Or would you just have just two sites up?
Okay. So first thing, we haven't started the lab yet. I will explain you that how you're gonna have access to the labs, right? Because since it was not needed for us to have the lab access so far, as I told you that from next Sunday we will be starting the labs, and the first thing that I would cover is that how to access the lab. Right?
Okay. In that case, we'll leave that question.
Yeah. Second is
the second one.
Okay, go on.
So with the SD-WAN, you drew a diagram with some DCs, MPLS, and backhaul, and you mentioned in the lecture that some of the sites you need DIA, direct internet access across the SD-WAN. The SD-WAN would perform some actions. Now, does SD-WAN provide WAN acceleration or bandwidth minimization when you manage the sites? Would it make redundant products from Riverbed with their WAN accelerator or the Citrix branch repeater that you would have at the various branch sites?
So in Cisco SD-WAN, they have a feature called WAN optimization.
Yeah.
But do not compare it with Silver Peak or the other product. Why? Because Cisco has got very limited functionality when it comes to the WAN optimizer. Right?
Okay, so you would still need those products.
So no, you don't need them. Why? Because whatever you need, it probably you get what you want. But yeah, I mean, if you are looking for the dedicated optimizer, then you should have them bring in. At least it can perform the TCP optimization. Like if you wanted to reuse the TCP connection, at that level only it can perform the optimization. But yeah, I mean, when it comes to the let's say the drop avoidance, maybe you want reliability that you can get with Cisco SD-WAN, right? You don't need any other devices.
The last question, you gave us a very good example of integrating with ServiceNow, an API, where it automatically logs a service ticket. What sort of controls did you put for situations where a router might have a port flapping up and down? Because if you have a too short of interval, ServiceNow will record multiple service tickets that a router has been down.
So if that was happening on a same device and then same port number was flapping, then it was simply updating the ticket, the existing ticket, that it has came up now, and then it has gone down again. So it was updating the ticket, not creating a new ticket.
Okay. Okay. I just wanted to clarify because I've had instances where a particular router has been flapping and creating lots of chatter. That's it for me.
Anybody else? No? Okay. Thank you all. Then see you next week and bye for now.